an aerial view of more than 20 circular crop fields of different sizes. Their varying colors indicate different crops or growing patterns. From the air, a landscape of circular crop fields may seem random, but they are laid out and irrigated very precisely. Farmers and irrigation providers combining agricultural science, engineering, and mathematics to achieve the most productive and efficient array. Credit: Modification of aerial photo of center pivot irrigation systems, 1, by Soil Science/Flickr. Chapter outline: 2. 1. The rectangular coordinate systems and graphs. 2. 2 linear equations in one variable. 2. 3 models and applications. 2. 4 complex numbers. 2. 5 quadratic equations. 2. 6 other types of equations. 2. 7 linear inequalities and absolute value inequalities. Irrigation is a critical aspect of agriculture, which can expand the yield of farms and enable farming in areas not naturally viable for crops. But the materials, equipment, and the water itself are expensive and complex. To be efficient and productive, farm owners and irrigation specialists must carefully lay out the network of pipes, pumps, and related equipment. The available land can be divided into regular portions, similar to a grid, and the different sizes of irrigation systems and conduits can be installed within the plotted area. Learning objectives. In this section, you will plot ordered pairs in a Cartesian coordinate system, graph equations by plotting points, graph equations with a graphing utility, find x-intercepts and y-intercepts, use the distance formula, use the midpoint formula, road map of a city with street names on an x, y coordinate grid. Various points are marked in red on the grid lines, indicating different locations on the map. Figure 1. Tracy set out from Elmhurst, IL, to go to Franklin Park. On the way, she made a few stops to do errands. Each stop is indicated by a red dot in Figure 1. Laying a rectangular coordinate grid over the map, we can see that each stop aligns with an intersection of grid lines. In this section, we will learn how to use grid lines to describe locations and changes in locations. Plotting ordered pairs in the Cartesian coordinate system. An old story describes how 17th century philosopher-mathematician René Descartes, while sick in bed, invented the system that has become the foundation of algebra. According to the story, Descartes was staring at a fly crawling on the ceiling when he realized that he could describe the fly's location in relation to the perpendicular lines formed by the adjacent walls of his room. He viewed the perpendicular lines as horizontal and vertical axes. Further, by dividing each axis into equal unit lengths, Descartes saw that it was possible to locate any object in a two-dimensional plane using just two numbers: the displacement from the horizontal axis and the displacement from the vertical axis. While there is evidence that ideas similar to Descartes' grid system existed centuries earlier, it was Descartes who introduced the components that comprise the Cartesian coordinate system, a grid system having perpendicular axes. Descartes named the horizontal axis the x-axis and the vertical axis the y-axis. The Cartesian coordinate system, also called the rectangular coordinate system, is based on a two-dimensional plane consisting of the x-axis and the y-axis. Perpendicular to each other, the axes divide the plane into 4 sections. Each section is called a quadrant. The quadrants are numbered counterclockwise as shown in Figure 2. This is an image of an x, y plane with the axes labeled. The upper right section is labeled Quadrant I. The upper left section is labeled Quadrant II. The lower left section is labeled Quadrant III. The lower right section is labeled Quadrant IV. Figure 2. The center of the plane is the point at which the two axes cross. It is known as the origin or point 0. From the origin, each axis is further divided into equal units, increasing positive numbers to the right on the x-axis and up the y-axis, decreasing negative numbers to the left on the x-axis and down the y-axis. The axes extend to positive and negative infinity as shown by the arrowheads in Figure 3. This is an image of an x, y coordinate plane. The x and y-axis range from -5 to 5. Figure 3. Each point in the plane is identified by its x-coordinate, or horizontal displacement from the origin, and its y-coordinate, or vertical displacement from the origin. Together, we write them as an ordered pair indicating the combined distance from the origin in the form xy. An ordered pair is also known as a coordinate pair because it consists of x and y coordinates. For example, we can represent the point 3, -1 in the plane by moving 3 units to the right of the origin in the horizontal direction and 1 unit down in the vertical direction. See Figure 4. This is an image of an x, y coordinate plane. The x and y axis range from -5 to 5. The point 3, -1 is labeled. An arrow extends rightward from the origin 3 units, and another arrow extends downward 1 unit from the end of that arrow to the point. Figure 4. When dividing the axes into equally spaced increments, note that the x-axis may be considered separately from the y-axis. In other words, while the x-axis may be divided and labeled according to consecutive integers, the y-axis may be divided and labeled by increments of 2, or 10, or 100. In fact, the axes may represent other units, such as years against the balance in a savings account or quantity against cost, and so on. Consider the rectangular coordinate system primarily as a method for showing the relationship between two quantities. Cartesian coordinate system, a two-dimensional plane where the x-axis is the horizontal axis, y-axis is the vertical axis. A point in the plane is defined as an ordered pair, xy, such that x is determined by its horizontal distance from the origin, and y is determined by its vertical distance from the origin. Example 1. Plotting points in a rectangular coordinate system. Plot the points -2, 4, 33, and 0, -3. In the plane, analysis, note that when either coordinate is 0, the point must be on an axis. If the x-coordinate is 0, the point is on the y-axis. If the y-coordinate is 0, the point is on the x-axis. Graphing equations by plotting points. We can plot a set of points to represent an equation. When such an equation contains both an x variable and a y variable, it is called an equation in two variables. Its graph is called a graph in two variables. Any graph on a two-dimensional plane is a graph in two variables. Suppose we want to graph the equation letter 1d466 equals 2 letter 1d465 -1. We can begin by substituting a value for x into the equation and determining the resulting value of y. Each pair of x and y values is an ordered pair that can be plotted. Table 1 lists values of x from 3 to 3 and the resulting values for y. X, letter 1d466, equals 2 letter 1d465 -1. X, y, -3. Letter 1d466 equals 2, -3 -1 equals -7, -3, -7, -2. Letter 1d466 equals 2, -2, -1 equals -5, -2, -5, -1. Letter 1d466 equals 2, -1 -1 equals -3, -1 -3, 0. Letter 1d466 equals 2, 0. -1 equals -1, 0, -1, 1. Letter 1d466 equals 2, 1 -1 equals 1, 1, 2, 2, 3, 3. Letter 1d466 equals 2, 3, -1 equals 5, 3 5s. Table 1. We can plot the points in the table. The points for this particular equation form a line so we can connect them. See Figure 6. This is not true for all equations. This is a graph of a line on an x, y coordinate plane. The x and y-axis range from -8 to 8. A line passes through the points -3, -7, -2, -5, -1, 0, -1, 1, 1, 2, 3, and 3, 5, Figure 6. Note that the x values chosen are arbitrary, regardless of the type of equation we are graphing. Of course, some situations may require particular values of x to be plotted in order to see a particular result. Otherwise, it is logical to choose values that can be calculated easily, and it is always a good idea to choose values that are both negative and positive. There is no rule dictating how many points to plot, although we need at least 2 to graph a line. Keep in mind, however, that the more points we plot, the more accurately we can sketch the graph. How to? Given an equation, graph by plotting points. Make a table with one column labeled x, a second column labeled with the equation, and a third column listing the resulting ordered pairs. Enter x values down the first column using positive and negative values. Selecting the x values in numerical order will make the graphing simpler. Select x values that will yield y values with little effort, preferably ones that can be calculated mentally. Plot the ordered pairs. Connect the points if they form a line. Example 2. Graphing an equation in two variables by plotting points. Graph the equation letter 1d466 equals minus letter 1d465 plus 2. By plotting points. Solution. First, we construct a table similar to Table 2. Choose x values and calculate y. X, letter 1d466 equals minus letter 1d465 plus 2. X, y, minus 5. Letter 1d466 equals minus 5 plus 2 equals 7. Minus 5, 7, minus 3. Letter 1d466 equals minus 3 plus 2 equals 5. Minus 3, 5. Minus 1. Letter 1d466 equals minus 1 plus 2 equals 3. Minus 1, 3, 0. Letter 1d466 equals minus 0 plus 2 equals 2. 0, 2. 1, 1, 1, 3. Letter 1d466 equals minus 3 plus 2 equals minus 1. 3 minus 1. 5. Letter 1d466 equals minus 5 plus 2 equals minus 3. 5 minus 3. Table 2. Now, plot the points. Connect them if they form a line. See Figure 7. This image is a graph of a line on an x, y coordinate plane. The x-axis includes numbers that range from -7 to 7. The y-axis includes numbers that range from -5 to 8. A line passes through the points. -5, 7, -3, 5, -1, 3, 0, 2, 1, 1, 3, -1, and 5, -3, Figure 7. Try it 1. Construct a table and graph the equation by plotting points. Letter 1d466 equals 12 letter 1d465 plus 2. Graphing equations with a graphing utility. Most graphing calculators require similar techniques to graph an equation. The equations sometimes have to be manipulated, so they are written in the style letter 1d466 equals. The T84 Plus and many other calculator makes and models have a mode function, which allows the window, the screen for viewing the graph, to be altered so the pertinent parts of a graph can be seen. For example, the equation letter 1d466 equals 2 letter 1d465 minus 20 has been entered in the T84 Plus shown in Figure 8a. In Figure 8b, the resulting graph is shown. Notice that we cannot see on the screen where the graph crosses the axes. The standard window screen on the T84 Plus shows minus 10 less or equal to letter 1d465 less or equal to 10, and minus 10 less or equal to letter 1d466 less or equal to 10. See Figure 8c. This is an image of 3 side-by-side calculator screen captures. The first screen is the plot screen with the function y sub 1 equals 2 times x minus 20. The second screen shows the plotted line on the coordinate plane. The third screen shows the window edit screen with the following settings: xmin equals, xmax equals 10, xscl equals 1, imin equals, imax equals 10, iscal equals 1, xres equals 1. Figure 8a. Enter the equation. B. This is the graph in the original window. C. These are the original settings. By changing the window to show more of the positive x-axis and more of the negative y-axis, we have a much better view of the graph and the x and y-intercepts. See Figure 9a and Figure 9b. This is an image of 2 side-by-side calculator screen captures. The first screen is the window edit screen with the following settings: xmin equals -5, xmax equals 15, xscl equals 1, imin equals, imax equals 10, iscal equals 1, xres equals 1. The second screen shows the plot of the previous graph but is more centered on the line. Figure 9a. This screen shows the new window settings. B. We can clearly view the intercepts in the new window. Example 3. Using a graphing utility to graph an equation. Use a graphing utility to graph the equation. Letter 1d466 equals minus 23 letter 1d465 plus 43. Solution. Enter the equation in the y equals function of the calculator. Set the window settings so that both the x and y intercepts are showing in the window. See Figure 10. This image is of a line graph on an x, y coordinate plane. The x-axis has numbers that range from -3 to 4. The y-axis has numbers that range from -3 to 3. The function y equals -2x3 plus 4,3 is plotted. Figure 10. Finding x-intercepts and y-intercepts. The intercepts of a graph are points at which the graph crosses the axes. The x-intercept is the point at which the graph crosses the x-axis. At this point, the y-coordinate is 0. The y-intercept is the point at which the graph crosses the y-axis. At this point, the x-coordinate is 0. To determine the x-intercept, we set y equal to 0 and solve for x similarly. To determine the y-intercept, we set x equal to 0 and solve for y. For example, let's find the intercepts of the equation letter 1d466 equals 3 letter 1d465 minus 1. To find the x-intercept, set letter 1d466 equals 0. Letter 1d466 equals 3 letter 1d465 minus 10 equals 3 letter 1d465 minus 11 equals 3 letter 1d465, 13 equals letter 1d465. 13. 0 letter 1d465 minus intercept. To find the y-intercept, set letter 1d466 equals 3 letter 1d465 minus 1 letter 1d466 equals 3. 0. Minus 1 letter 1d466 equals minus 1. 0. Minus 1 letter 1d466 minus intercept. We can confirm that our results make sense by observing a graph of the equation, as in Figure 11. Notice that the graph crosses the axes where we predicted it would. This is an image of a line graph on an x, y coordinate plane. The x and y-axis range from -4 to 4. The function y equals 3x. 1 is plotted on the coordinate plane. Figure 12. Try it too. Find the intercepts of the equation and sketch the graph. Letter 1d466 equals minus 34 letter 1d465 plus 3. Using the distance formula, derived from the Pythagorean theorem, the distance formula is used to find the distance between 2 points in the plane. The Pythagorean theorem, letter 1d440, 2, plus letter 1d44f, 2, equals letter 1d4502, is based on a right triangle where A and B are the lengths of the legs adjacent to the right angle, and C is the length of the hypotenuse. See Figure 13. This is an image of a triangle on an x, y coordinate plane. The x and y axes range from 0 to 7. The points x sub 1, y sub 1, x sub 2, y sub 1, and x sub 2, y sub 2 are labeled and connected to form a triangle. Along the base of the triangle, the following equation is displayed. The absolute value of x sub 2 minus x sub 1 equals a. The hypotenuse of the triangle is labeled. D equals c, the remaining side is labeled. The absolute value of y sub 2 minus y sub 1 equals b. Figure 13. The relationship of sides letter 1d465, 2 minus letter 1d465, 1, and letter 1d466, 2, minus letter 1d466, 1. To side D is the same as that of sides A and B to side C. We use the absolute value symbol to indicate that the length is a positive number because the absolute value of any number is positive. For example, minus 3 equals 3. The symbols letter 1d465, 2 minus letter 1d465, 1, and letter 1d466, 2, minus letter 1d466, 1, indicate that the lengths of the sides of the triangle are positive. To find the length C, take the square root of both sides of the Pythagorean theorem. Letter 1d4502 equals letter 1d440, 2, plus letter 1d44f. 2 right arrow letter 1d450 equals letter 1d440, 2, plus letter 1d44f, 2 square. It follows that the distance formula is given as letter 1d4512 equals letter 1d465, 2 minus letter 1d465, 1, 2 plus letter 1d466, 2 minus letter 1d466, 1, 2 right arrow letter 1d451 equals letter 1d465, 2 minus letter 1d465, 1, 2 plus letter 1d466, 2 minus letter 1d466, 1, 2 square. We do not have to use the absolute value symbols in this definition because any number squared is positive. The distance formula, given endpoints x1, y1, and x2, y2, the distance between 2 points is given by Letter 1D451 equals letter 1D465 2 minus letter 1D465 1 2 plus letter 1D466 2 minus letter 1D466 1 2 square. Example 5. Finding the distance between 2 points. Find the distance between the points -3, -1, and 2 3. Try it 3. Find the distance between 2 points 14 and 119. Example 6. Finding the distance between 2 locations. Let's return to the situation introduced at the beginning of this section. Tracy set out from Elmhurst, IL, to go to Franklin Park. On the way, she made a few stops to do errands. Each stop is indicated by a red dot in Figure 1. Find the total distance that Tracy traveled. Compare this with the distance between her starting and final positions. Solution. The first thing we should do is identify ordered pairs to describe each position. If we set the starting position at the origin, we can identify each of the other points by counting units east, right, and north, up on the grid. For example, the first stop is 1 block east and 1 block north, so it is at 11. The next stop is 5 blocks to the east, so it is at 51. After that, she traveled 3 blocks east and 2 blocks north to 83. Lastly, she traveled 4 blocks north to 87. We can label these points on the grid as in Figure 15. This is an image of a road map of a city. The point 1, 1 is on North Avenue and Bertow Avenue. The point 5, 1 is on North Avenue and Wolf Road. The point 8, 3 is on Mannheim Road and McLean Street. The point 8, 7 is on Mannheim Road and Schiller Avenue. Figure 15. Next, we can calculate the distance. Note that each grid unit represents 1,000 feet. From her starting location to her first stop at 11, Tracy might have driven north 1,000 feet and then east 1,000 feet, or vice versa. Either way, she drove 2,000 feet to her first stop. Her second stop is at 51, so from 11 to 51, Tracy drove east 4,000 feet. Her third stop is at 83. There are a number of routes from 51 to 83. Whatever route Tracy decided to use, the distance is the same, as there are no angular streets between the 2 points. Let's say she drove east 3,000 feet and then north 2,000 feet for a total of 5,000 feet. Tracy's final stop is at 87. This is a straight drive north from 83, for a total of 4,000 feet. Next, we will add the distances listed in Table 3, from slash to number of feet driven, 0 to 11, 2,000, 11 to 51, 4,000, 51 to 83, 5,000, 83 to 87, 4,000, total 15, 000. Table 3. The total distance Tracy drove is 15,000 feet, or 84 miles. This is not, however, the actual distance between her starting and ending positions. To find this distance, we can use the distance formula between the points 0 and 87. Letter 1D451 equals 8 minus 0, 2 plus 7 minus 0, 2 square equals 64 plus 49 square equals 113, square approximately 10. Units. At 1,000 feet per grid unit, the distance between Elmhurst, IL, to Franklin Park is 10,630. 14 feet, or 21 miles. The distance formula results in a shorter calculation because it is based on the hypotenuse of a right triangle, a straight diagonal from the origin to the point 87. Perhaps you have heard the saying, as the crow flies, which means the shortest distance between 2 points, because a crow can fly in a straight line even though a person on the ground has to travel a longer distance on existing roadways. Using the midpoint formula, when the endpoints of a line segment are known, we can find the point midway between them. This point is known as the midpoint, and the formula is known as the midpoint formula. Given the endpoints of a line segment, x1, y1, and x2, y2, the midpoint formula states how to find the coordinates of the midpoint letter 1D440. Letter 1D440 equals letter 1D465 1 plus letter 1D465 22, letter 1D466 1 plus letter 1D466 22. A graphical view of a midpoint is shown in Figure 16. Notice that the line segments on either side of the midpoint are congruent. This is a line graph on an x, y coordinate plane with the x and y axes ranging from 0 to 6. The points x sub 1, y sub 1, x sub 2, y sub 2, and x sub 1 plus x sub 2 all over 2, y sub 1 plus y sub 2 all over 2 are plotted. A straight line runs through these 3 points. Pairs of short parallel lines bisect the 2 sections of the line to note that they are equivalent. Figure 16. Example 7. Finding the midpoint of the line segment. Find the midpoint of the line segment with the endpoints 7 minus 2 and 95. Solution. Use the formula to find the midpoint of the line segment. Letter 1d465 1 plus letter 1d465 22, letter 1d466 1 plus letter 1d466 22 equals 7 plus 92, minus 2 plus 52 equals 8, 32. Try it 4. Find the midpoint of the line segment with endpoints minus 2, minus 1, and minus 8, 6. Example 8. Finding the center of a circle. The diameter of a circle has endpoints minus 1, minus 4, and 5, minus 4. Find the center of the circle. Solution. The center of a circle is the center, or midpoint, of its diameter. Thus, the midpoint formula will yield the center point. Letter 1d465 1 plus letter 1d465 22, letter 1d466 1 plus letter 1d466 22. Minus 1 plus 52 minus 4 minus 42 equals 42, minus 82 equals 2 minus 4. Media. Access these online resources for additional instruction and practice with the Cartesian coordinate system. Plotting points on the coordinate plane. Find x and y intercepts based on the graph of a line. 2 one-section exercises. Verbal. 1. Is it possible for a point plotted in the Cartesian coordinate system to not lie in one of the 4 quadrants? Explain. 2. Describe the process for finding the x-intercept and the y-intercept of a graph algebraically. 3. Describe in your own words what the y-intercept of a graph is. 4. When using the distance formula, letter 1d451 equals letter 1d465 2 minus letter 1d465 1 2 plus letter 1d466 2 minus letter 1d466 1 2 square. Explain the correct order of operations that are to be performed to obtain the correct answer. Algebraic. For each of the following exercises, find the x-intercept and the y-intercept without graphing. Write the coordinates of each intercept. 5. Letter 1d466 equals minus 3 letter 1d465 plus 6. 6. 4 letter 1d466 equals 2 letter 1d465 minus 1. 7. 3 letter 1d465 minus 2 letter 1d466 equals 6. 8. 4 letter 1d465 minus 3 equals 2 letter 1d466. 9. 3 letter 1d465 plus 8 letter 1d466 equals 9. 10. 2 letter 1d465 minus 23 equals 34 letter 1d466 plus 3. For each of the following exercises, solve the equation for y in terms of x11. 4 letter 1d465 plus 2 letter 1d466 equals 8. 12. 3 letter 1d465 minus 2 letter 1d466 equals 6. 13. 2 letter 1d465 equals 5 minus 3 letter 1d466. 14. Letter 1d465 minus 2 letter 1d466 equals 7. 15. 5 letter 1d466 plus 4 equals 10 letter 1d465. 16. 5 letter 1d465 plus 2 letter 1d466 equals 0. For each of the following exercises, find the distance between the 2 points. Simplify your answers and write the exact answer in simplest radical form for irrational answers. 17. Minus 4, 1. And 3 minus 4. 18, 2 minus 5. And 74. 19. 50. And 56. 20 minus 4, 3. And 103. 21. Find the distance between the 2 points given using your calculator and round your answer to the nearest hundredth. 1,912 and 4,171. For each of the following exercises, find the coordinates of the midpoint of the line segment that joins the 2 given points. 22, minus 5 minus 6, and 42. 23, minus 1, 1, and 7 minus 4. 24, minus 5 minus 3, and minus 2 minus 8. 25, 7, and 4 minus 9. 26, minus 43, 17, and 23 minus 34. Graphic. For each of the following exercises, Identify the information requested. 27. What are the coordinates of the origin? 28. If a point is located on the y-axis, what is the x-coordinate? 29. If a point is located on the x-axis, what is the y-coordinate? For each of the following exercises, plot the 3 points on the given coordinate plane. State whether the 3 points you plotted appear to be collinear on the same line. 30. 4, 1, minus 2, minus 3, 5, 0. This is an image of a blank x. Y-coordinate plane with the x and y-axes ranging from -5 to 5, 31. Minus 1, 2, 0, 4, 2, 1. This is an image of a blank x. Y-coordinate plane with the x and y-axes ranging from -5 to 5, 32. Minus 3, 0, minus 3, 4, minus 3, minus 3. This is an image of a blank x. Y-coordinate plane with the x and y-axes ranging from -5 to 5, 33. Name the coordinates of the points graphed. This is an image of an x, y-coordinate plane where the x and y-axis range from -5 to 5. 3 points are plotted, A, B, and C 34. Name the quadrant in which the following points would be located. If the point is on an axis, name the axis. A -3 minus 4, B -5 0, C1 -4, D -2 7, E0 -3. For each of the following exercises, construct a table and graph the equation by plotting at least 3 points. 35. Letter 1D466 equals 13 letter 1D465 plus 2. 36. Letter 1D466 equals minus 3 letter 1D465 plus 1. 37. 2 letter 1D466 equals letter 1D465 plus 3. Numeric. For each of the following exercises, find and plot the x and y-intercepts and graph the straight line based on those 2 points. 38. 4 letter 1D465 minus 3 letter 1D466 equals 12. 39. Letter 1D465 minus 2 letter 1D466 equals 8. 40. Letter 1D466 minus 5 equals 5 letter 1D465. 41. 3 letter 1D466 equals minus 2 letter 1D465 plus 6. 42. Letter 1D466 equals letter 1D465 minus 32. For each of the following exercises, use the graph in the figure below. This is an image of an x, y-coordinate plane with the x and y-axes ranging from -5 to 5. The points -3, 4, and 5, 2 are plotted. A line connects these 2 points. 43. Find the distance between the 2 endpoints using the distance formula. Round to 3 decimal places. 44. Find the coordinates of the midpoint of the line segment connecting the 2 points. 45. Find the distance that -3, 4 is from the origin. 46. Find the distance that 52 is from the origin. Round to 3 decimal places. 47. Which point is closer to the origin? Technology. For the following exercises, use your graphing calculator to input the linear graphs in the y equals graph menu. After graphing it, use the second CALC button and 1 value button, hit enter. At the lower part of the screen, you will see X and a blinking cursor. You may enter any number for X, and it will display the Y value for any X value you input. Use this and plug in X equals 0, thus finding the y-intercept for each of the following graphs. 48. Y1 equals minus 2 letter 1D465 plus 5. 49. Y1 equals 3 letter 1D465 minus 84. 50. Y1 equals letter 1D465 plus 52. For the following exercises, use your graphing calculator to input the linear graphs in the y equals graph menu. After graphing it, use the second CALC button and 2, 0 button, hit enter. At the lower part of the screen, you will see left bound and a blinking cursor on the graph of the line. Move this cursor to the left of the x-intercept, hit enter. Now it says right bound. Move the cursor to the right of the x-intercept, hit enter. Now it says guess. Move your cursor to the left somewhere in between the left and right bound near the x-intercept. Hit enter. At the bottom of your screen, it will display the coordinates of the x-intercept or the 0 to the y value. Use this to find the x-intercept. Note, with linear straight line functions, the 0 is not really a guess, but it is necessary to enter a guess, so it will search and find the exact x-intercept between your right and left boundaries. With other types of functions, more than one x-intercept, They may be irrational numbers, so guess is more appropriate to give it the correct limits to find a very close approximation between the left and right boundaries. 51. y1 equals minus 8 letter 1d465 plus 6. 52. y1 equals 4 letter 1d465 minus 7. 53. y1 equals 3 letter 1d465 plus 54. Round your answer to the nearest thousandth. Extensions. 54. Someone drove 10 mi directly east from their home, made a left turn at an intersection, and then traveled 5 mi north to their place of work. If a road was made directly from the home to the place of work, what would its distance be to the nearest tenth of a mile? 55. If the road was made in the previous exercise, how much shorter would the person's one-way trip be every day? 56. Given these 4 points, letter 1d434, 1 3. Letter 1d435, 3 5. Letter 1d436, 4 7. And letter 1d437, 5 4. Find the coordinates of the midpoint of line segments AB and CD. 57. After finding the 2 midpoints in the previous exercise, find the distance between the 2 midpoints to the nearest thousandth. 58. Given the graph of the rectangle shown and the coordinates of its vertices, prove that the diagonals of the rectangle are of equal length. This is an image of an x, y coordinate plane with the x and y axes ranging from -12 to 12. The points -6, 5, 10, 5, -6, -1, and 10, -1 are plotted and labeled. These points are connected to form a rectangle. Dotted lines extend from each corner point to their opposite point. 59. In the previous exercise, find the coordinates of the midpoint for each diagonal. Real-world applications. 60. The coordinates on a map for San Francisco are 5,317, and those for Sacramento are 12,878. Note that coordinates represent miles. Find the distance between the cities to the nearest mile. 61. If San Jose's coordinates are 7612, where the coordinates represent miles, find the distance between San Jose and San Francisco to the nearest mile. 62. A small craft in Lake Ontario sends out a distress signal. The coordinates of the boat in trouble were 4,964. One rescue boat is at the coordinates 6,082, and a second Coast Guard craft is at coordinates 5,847. Assuming both rescue craft travel at the same rate, which one would get to the distressed boat the fastest? 63. A person on the top of a building wants to have a guy wire extend to a point on the ground 20 ft from the building. To the nearest foot, how long will the wire have to be if the building is 50 ft tall? A right triangle with its bottom left point sitting on the point 0. The upper right-hand corner is labeled 2050. The base has a length of 20 units and the triangle has a height of 50 units. 64. If we rent a truck and pay a $75 day fee plus 20 for every mile we travel, write a linear equation that would express the total cost per day letter 1d466, using letter 1d465, to represent the number of miles we travel. Graph this function on your graphing calculator and find the total cost for one day if we travel 70 mi. Learning objectives. In this section, you will solve equations in one variable algebraically, solve a rational equation, find a linear equation. Given the equations of 2 lines, determine whether their graphs are parallel or perpendicular. Write the equation of a line parallel or perpendicular to a given line. Caroline is a full-time college student planning a spring break vacation. To earn enough money for the trip, she has taken a part-time job at the local bank that pays $15/HR, and she opened a savings account with an initial deposit of $400 on January 15. She arranged for direct deposit of her payroll checks. If spring break begins March 20 and the trip will cost approximately $2,500, how many hours will she have to work to earn enough to pay for her vacation? If she can only work 4 hours per day, how many days per week will she have to work? How many weeks will it take? In this section, we will investigate problems like this and others, which generate graphs like the line in Figure 1. Coordinate plane, where the x-axis ranges from 0 to 200 in intervals of 20, and the y-axis ranges from 0 to 3,000 in intervals of 500. The x-axis is labeled hours worked, and the y-axis is labeled savings account balance. A linear function is plotted with a y-intercept of 400 with a slope of 15. A dotted horizontal line extends from the point 2500. Figure 1. Solving linear equations in one variable. A linear equation is an equation of a straight line, written in one variable. The only power of the variable is 1. Linear equations in one variable may take the form letter 1d44 letter 1d465 plus letter 1d44f equals 0, and are solved using basic algebraic operations. We begin by classifying linear equations in one variable as one of three types: identity, conditional, or inconsistent. An identity equation is true for all values of the variable. Here is an example of an identity equation. 3 letter 1d465 equals 2 letter 1d465 plus letter 1d465. The solution set consists of all values that make the equation true. For this equation, the solution set is all real numbers, because any real number substituted for x will make the equation true. A conditional equation is true for only some values of the variable. For example, if we are to solve the equation 5 letter 1d465 plus 2 equals 3 letter 1d465 minus 6, we have the following: 5 letter 1d465 plus 22 letter 1d465 equals 3 letter 1d465 minus 6 minus 8 minus 4. The solution set consists of one number, minus 4. It is the only solution, and therefore, we have solved a conditional equation. An inconsistent equation results in a false statement. For example, if we are to solve 5 letter 1d465 minus 15 equals 5 letter 1d465 minus 4, we have the following: 5 letter 1d465 minus 155 letter 1d465 minus 15 minus 5 letter 1d465 minus 15 equals not 5 letter 1d465 minus 200, 5 letter 1d465 minus 20 minus 5 letter 1d465 minus 20. Subtract 5 letter 1d465 from both sides. False statement. Indeed, minus 15 not minus 20. There is no solution because this is an inconsistent equation. Solving linear equations in one variable involves the fundamental properties of equality and basic algebraic operations. A brief review of those operations follows. Linear equation in one variable. A linear equation in one variable can be written in the form letter 1d44 letter 1d465 plus letter 1d44f equals 0, where a and b are real numbers. Letter 1d44 not equal to 0. How to? Given a linear equation in one variable, use algebra to solve it. The following steps are used to manipulate an equation and isolate the unknown variable, so that the last line reads letter 1d465 equals. If x is the unknown, there is no set order, as the steps used depend on what is given. We may add, subtract, multiply, or divide an equation by a number or an expression as long as we do the same thing to both sides of the equal sign. Note that we cannot divide by 0. Apply the distributive property as needed. Letter 1d44 letter 1d44f plus letter 1d450 equals letter 1d44 letter 1d44f plus letter 1d44 letter 1d450. Isolate the variable on one side of the equation. When the variable is multiplied by a coefficient in the final stage, multiply both sides of the equation by the reciprocal of the coefficient. Example 1. Solving an equation in one variable. Solve the following equation: 2 letter 1d465 plus 7 equals 19. Solution. This equation can be written in the form letter 1d44 letter 1d465 plus letter 1d44f equals 0 by subtracting 19 from both sides. However, we may proceed to solve the equation in its original form by performing algebraic operations. 2 letter 1d465 plus 72 letter 1d465 letter 1d465 equals 19,126. Subtract 7 from both sides. Multiply both sides by 12 or divide by 2. The solution is 6. Try it 1. Solve the linear equation in one variable. 2 letter 1d465 plus 1 equals minus 9. Example 2. Solving an equation algebraically when the variable appears on both sides. Solve the following equation. 4 letter 1d465 minus 3 plus 12 equals 15 minus 5 letter 1d465 plus 6. Solution. Apply standard algebraic properties. 4, letter 1 d465 minus 3, plus 124 letter 1 d465 minus 12, plus 124 letter 1 d465, 9 letter 1 d465 letter 1 d465 letter 1 d465 equals 15 minus 5. Letter 1 d465 plus 6 of 15 minus 5 letter 1 d465 minus 30 minus 15 minus 5 letter 1 d465 minus 15 minus 159 minus. The distributive property. Combine like terms. Place x terms on one side and simplify. Multiply both sides by 19, the reciprocal of 9. Analysis. This problem requires the distributive property to be applied twice, and then the properties of algebra are used to reach the final line, letter 1 d465 equals minus 53. Try it too. Solve the equation in one variable. Minus 2, 3 letter 1 d465 minus 1 plus letter 1 d465 equals 14 minus letter 1 d465. Solving a rational equation. In this section, we look at rational equations that, after some manipulation, result in a linear equation. If an equation contains at least one rational expression, it is considered a rational equation. Recall that a rational number is the ratio of two numbers, such as 23 or 72. A rational expression is the ratio or quotient of two polynomials. Here are 3 examples. Letter 1 d465 plus 1 letter 1 d465 2 minus 4, 1 letter 1 d465 minus 3, or 4 letter 1 d465 2 plus letter 1 d465 minus 2. Rational equations have a variable in the denominator in at least one of the terms. Our goal is to perform algebraic operations so that the variables appear in the numerator. In fact, we will eliminate all denominators by multiplying both sides of the equation by the least common denominator, LCD. Finding the LCD is identifying an expression that contains the highest power of all of the factors in all of the denominators. We do this because when the equation is multiplied by the LCD, the common factors in the LCD and in each denominator will equal 1 and will cancel out. Example 3. Solving a rational equation. Solve the rational equation. 72 letter 1 d465 minus 53 letter 1 d465 equals 223. Solution. We have 3 denominators, 2x, 3x, and 3. The LCD must contain 2x, 3x, and 3. An LCD of 6x contains all 3 denominators. In other words, each denominator can be divided evenly into the LCD. Next, multiply both sides of the equation by the LCD 6x. 6 letter 1 d465. 72 letter 1 d465 minus 53 letter 1 d465. 6 letter 1 d465. 72 letter 1 d465 minus 6 letter 1 d465. 53 letter 1 d465. 6 letter 1 d465. 72 letter 1 d465 minus 6 letter 1 d465. 53 letter 1 d465 3. 7 minus 2 5 21 minus 1 billion 11 million. The distributive property. Cancel out the common factors. Multiply remaining factors by each numerator. A common mistake made when solving rational equations involves finding the LCD when one of the denominators is a binomial, 2 terms added or subtracted, such as x plus 1. Always consider a binomial as an individual factor. The terms cannot be separated. For example, suppose a problem has 3 terms and the denominators are x. Letter 1 d465 minus 1, and 3 letter 1 d465 minus 3. First, factor all denominators. We then have x, letter 1 d465 minus 1, and 3 letter 1 d465 minus 1. As the denominators, note the parentheses placed around the second denominator. Only the last 2 denominators have a common factor of letter 1 d465 minus 1. The x, in the first denominator, is separate from the x in the letter 1 d465 minus 1. Denominators. An effective way to remember this is to write factored and binomial denominators in parentheses, and consider each parentheses as a separate unit or a separate factor. The LCD in this instance is found by multiplying together the x, one factor of letter 1 d465 minus 1, and the 3. Thus, the LCD is the following. Letter 1 d465. Letter 1 d465 minus 1, 3 equals 3 letter 1 d465 letter 1 d465 minus 1. So, both sides of the equation would be multiplied by 3 letter 1d465, letter 1d465 minus 1. Leave the LCD in factored form, as this makes it easier to see how each denominator in the problem cancels out. Another example is a problem with two denominators, such as x and x2 plus 2x. Once the second denominator is factored as letter 1d465 plus 2 letter 1d465 equals letter 1d465. Letter 1d465 plus 2. There is a common factor of x in both denominators, and the LCD is letter 1d465. Letter 1d465 plus 2. Sometimes we have a rational equation in the form of a proportion. That is, when one fraction equals another fraction, and there are no other terms in the equation. Letter 1d44 letter 1d44f equals letter 1d450 letter 1d451. We can use another method of solving the equation without finding the LCD. Cross multiplication. We multiply terms by crossing over the equal sign. Multiply letter 1d44e, letter 1d451, and letter 1d44f, letter 1d450, which results in letter 1d44e, letter 1d451 equals letter 1d44f, letter 1d450. Any solution that makes a denominator in the original expression equal 0 must be excluded from the possibilities. Rational equations. A rational equation contains at least one rational expression where the variable appears in at least one of the denominators. How to? Given a rational equation, solve it. Factor all denominators in the equation. Find and exclude values that set each denominator equal to 0. Find the LCD. Multiply the whole equation by the LCD. If the LCD is correct, there will be no denominators left. Solve the remaining equation. Make sure to check solutions back in the original equations to avoid a solution producing 0 in a denominator. Example 4. Solving a rational equation without factoring. Solve the following rational equation. 2 letter 1d465 minus 32 equals 72 letter 1d465. Solution. We have three denominators, x, 2, and 2x. No factoring is required. The product of the first two denominators is equal to the third denominator, so the LCD is 2x. Only one value is excluded from a solution set, 0. Next, multiply the whole equation, both sides of the equal sign, by 2x. 2 letter 1d465, 2 letter 1d465, minus 32 2 letter 1d465, 2 letter 1d465, minus 2 letter 1d465, 32 2 minus 3 letter 1d465, 4 minus 3 letter 1d465, minus 3 letter 1d465 letter 1d465 equals 72 letter 1d465 2 letter 1d465. 72 letter 1d465 2 letter 1d465. 2x. Denominators cancel out. The proposed solution is minus 1, which is not an excluded value, so the solution set contains one number, minus 1, or minus 1, written in set notation. Try it 3. Solve the rational equation. 23 letter 1d465 equals 14 minus 16 letter 1d465. Example 5. Solving a rational equation by factoring the denominator. Solve the following rational equation. 1 letter 1d465 equals 110 minus 34 letter 1d465. Solution. First find the common denominator. The three denominators in factored form are letter 1d465, 10 equals 25, and 4 letter 1d465 equals 2 letter 1d465. The smallest expression, that is divisible by each one of the denominators, is 20x only, is an excluded value. Multiply the whole equation by 20x, 20 letter 1d465. 1 letter 1d465 2,035,352 equals 110 minus 34 letter 1d465 20 letter 1d465 to letter 1d465 minus 152 letter 1d465 letter 1d465. The solution is 352. Try it 4. Solve the rational equation. Minus 52 letter 1d465 plus 34 letter 1d465 equals minus 74. Example 6. Solving rational equations with a binomial in the denominator. Solve the following rational equations and state the excluded values. B letter 1d465 letter 1d465 minus 3 equals 5, letter 1 d465 minus 3 minus 12. C, letter 1 d465, letter 1 d465 minus 2 equals 5, letter 1 d465 minus 2 minus 12. Solution. The denominators x and letter 1 d465 minus 6 have nothing in common. Therefore, the LCD is the product letter 1 d465, letter 1 d465 minus 6. However, for this problem, we can cross-multiply. 3 letter 1 d465 minus 63 letter 1 d465, 3 letter 1 d465, minus 2 letter 1 d465 letter 1 d465 equals 5 letter 1 d465, 5 letter 1 d465, minus 6 of 5 letter 1 d465, minus 30 minus 3015 distribute. The solution is 15. The excluded values are 6 and 0. B. The LCD is 2, letter 1 d465 minus 3. Multiply both sides of the equation by 2, letter 1 d465 minus 3. 2 letter 1 d465 minus 3. Letter 1 d465 letter 1 d465 minus 3 2 letter 1 d465 minus 3. Letter 1 d465 letter 1 d465 minus 32 letter 1 d465 to x2. Letter 1 d465 3 letter 1 d465 letter 1 d465 equals 5 letter 1 d465 minus 3 minus 12 2 letter 1 d465 minus 3 2 letter 1 d465 minus 3 5 letter 1 d465 minus 3 minus 2 letter 1 d465 minus 3 210 minus letter 1 d465 minus 310 minus letter 1 d465 plus 313 minus letter 1 d465. The solution is 133. The excluded value is 3. C. The least common denominator is 2, letter 1 d465 minus 2. Multiply both sides of the equation by 2, letter 1 d465 minus 2. 2 letter 1 d465 minus 2. Letter 1 d465 letter 1 d465 minus 2 2, letter 1 d465 to letter 1 d465, 3 letter 1 d465 letter 1 d465 equals 5 letter 1 d465 minus 2 minus 12 2, letter 1 d465 minus 2 10 minus letter 1 d465 minus 2 12 minus letter 1 d465 124. The solution is 4. The excluded value is 2. Try it 5. Solve minus 32 letter 1 d465 plus 1 equals 43 letter 1 d465 plus 1. State the excluded values. Example 7. Solving a rational equation with factored denominators and stating excluded values. Solve the rational equation after factoring the denominators. 2 letter 1 d465 plus 1 minus 1 letter 1 d465 minus 1 equals 2 letter 1 d465 letter 1 d465 2 minus 1. State the excluded values. Solution. We must factor the denominator letter 1 d465 2 minus 1. We recognize this as the difference of squares and factor it as letter 1 d465 minus 1, letter 1 d465 plus 1. Thus, the LCD that contains each denominator is letter 1 d465 minus 1, letter 1 d465 plus 1. Multiply the whole equation by the LCD, cancel out the denominators, and solve the remaining equation. Letter 1 d465 minus 1, letter 1 d465 plus 1, 2 letter 1 d465 plus 1 minus 1 letter 1 d465 minus 1 2, letter 1 d465 minus 1, letter 1 d465 plus 1 2 letter 1 d465 minus 2 minus letter 1 d465 minus 1 minus 3 minus letter 1 d465 minus 3 equals 2 letter 1 d465, letter 1 d465 minus 1. To x distribute the negative sign. 0x, the solution is minus 3. The excluded values are 1 and minus 1. Try it 6. Solve the rational equation. 2 letter 1 d465 minus 2 plus 1 letter 1 d465 plus 1 equals 1 letter 1 d465, 2 minus letter 1 d465 minus 2. Finding a linear equation. Perhaps the most familiar form of a linear equation is the slope-intercept form. Written as letter 1 d466 equals letter 1 d45a letter 1 d465 plus letter 1 d44f, where slope and letter 1 d44f equals letter 1 d466 intercept. Let us begin with the slope of a line. The slope of a line refers to the ratio of the vertical change in y over the horizontal change in x between any 2 points on a line. It indicates the direction in which a line slants as well as its steepness. Slope is sometimes described as rise over run. Letter 1D45A equals letter 1D466, 2 minus letter 1D466, 1 letter 1D465, 2 minus letter 1D465, 1. If the slope is positive, the line slants upward to the right. If the slope is negative, the line slants downward to the right. As the absolute value of the slope increases, the line becomes steeper. Some examples are shown in Figure 2. The lines indicate the following slopes. Letter 1D45A equals -3. Letter 1D45A equals 2. And letter 1D45A equals 13. Coordinate plane with the x and y axes ranging from -10 to 10. Three linear functions are plotted. Y equals -3 times x minus 2, y equals 2 times x plus 1, and y equals x over 3 plus 2. Figure 2. The slope of a line, m, represents the change in y over the change in x given 2 points, x1, y1, and x2, y2. The following formula determines the slope of a line containing these points. Letter 1D45A equals letter 1D466, 2 minus letter 1D466, 1 letter 1D465, 2 minus letter 1D465. One example 8. Finding the slope of a line given 2 points. Find the slope of a line that passes through the points 2, -1, and -5, 3. Solution: we substitute the y values and the x values into the formula. The slope is -47. Analysis: it does not matter which point is called, x1, y1, or x2, y2. As long as we are consistent with the order of the y terms and the order of the x terms in the numerator and denominator, the calculation will yield the same result. Try it 7. Find the slope of the line that passes through the points -2, 6, and 14. Example 9. Identifying the slope and y-intercept of a line. Given an equation, identify the slope and y-intercept. Given the equation, letter 1D466 equals -34, letter 1D465 -4. Solution: as the line is in letter 1D466 equals letter 1D45A, letter 1D465, plus letter 1D44F form. The given line has a slope of letter 1D45A equals -34. The y-intercept is letter 1D44F equals -4. Analysis: the y-intercept is the point at which the line crosses the y-axis. On the y-axis, letter 1D465 equals 0. We can always identify the y-intercept when the line is in slope-intercept form, as it will always equal b, or just substitute letter 1D465 equals 0 and solve for y. The point-slope formula: given the slope and 1 point on a line, we can find the equation of the line using the point-slope formula. Letter 1D466 minus letter 1D466, 1 equals letter 1D45A. Letter 1D465 minus letter 1D465, 1. This is an important formula, as it will be used in other areas of college algebra and often in calculus to find the equation of a tangent line. We need only 1 point and the slope of the line to use the formula. After substituting the slope and the coordinates of 1 point into the formula, we simplify it and write it in slope-intercept form. The point-slope formula, given 1 point, and the slope. The point-slope formula will lead to the equation of a line. Letter 1D466 minus letter 1D466, 1 equals letter 1D45A. Letter 1D465 minus letter 1D465, 1. Example 10. Finding the equation of a line given the slope. And 1 point, write the equation of the line with slope letter 1D45A equals -3. And passing through the point, 48. Write the final equation in slope-intercept form. Solution: using the point-slope formula, substitute -3 for m and the point, 48, for x1, y1. Letter 1D466 minus letter 1D466, 1 letter 1D466 minus 8 letter 1D466, minus 8 letter 1D466 equals letter 1D45A. Letter 1D465 minus letter 1D465, 1, -3. Letter 1D465 -4. -3 letter 1D465 plus 12, -3 letter 1D465 plus 20. Analysis: note that any point on the line can be used to find the equation. If done correctly, the same final equation will be obtained. Try it 8. Given letter 1D45A equals 4, find the equation of the line in slope-intercept form passing through the point 25. Example 11, finding the equation of a line passing through two given points. Find the equation of the line passing through the points 34 and 0 minus 3. Write the final equation in slope-intercept form. Solution first, we calculate the slope using the slope formula and 2 points. Letter 1 d45a equals minus 3 minus 40 minus 3 minus 7 minus 373. Next, we use the point slope formula with the slope of 73 and either point. Let's pick the point 34 for x1, y1. Letter 1 d466 minus 4, letter 1 d466 minus 4, letter 1 d466 equals 73, letter 1 d465 minus 3, 73 letter 1 d465 minus 7, distribute the 73. 73 letter 1 d465 minus 3 in slope-intercept form. The equation is written as letter 1 d466 equals 73 letter 1 d465 minus 3. Analysis to prove that either point can be used. Let us use the second point, 0 minus 3, and see if we get the same equation. Letter 1 d466 minus 3 letter 1 d466 plus 3 letter 1 d466 equals 73. Letter 1 d465 minus 0. 73 letter 1 d465 73 letter 1 d465 minus 3. We see that the same line will be obtained using either point. This makes sense because we used both points to calculate the slope. Standard form of a line, another way that we can represent the equation of a line is in standard form. Standard form is given as letter 1 d434 letter 1 d465 plus letter 1 d435 letter 1 d466 equals letter 1 d436, where a, b, and c are integers. The x and y terms are on one side of the equal sign, and the constant term is on the other side. Example 12, finding the equation of a line and writing it in standard form. Find the equation of the line with letter 1 d45a equals minus 6 and passing through the point 14 minus 2. Write the equation in standard form. Solution, we begin using the point slope formula. Letter 1 d466 minus 2 letter 1 d466 plus 2 equals minus 6. Letter 1 d465 minus 14. Minus 6 letter 1 d465 plus 32. From here, we multiply through by 2, as no fractions are permitted in standard form, and then move both variables to the left side of the equal sign and move the constants to the right. 2, letter 1 d466 plus 2 letter 1 d466 plus 412 letter 1 d465 plus 2 letter 1 d466 equals minus 6 letter 1 d465 plus 32 2 minus 12 letter 1 d465 plus 3 minus 1. This equation is now written in standard form. Try at 9. Find the equation of the line in standard form with slope letter 1 d45a equals minus 13 and passing through the point 113. Vertical and horizontal lines. The equations of vertical and horizontal lines do not require any of the preceding formulas, although we can use the formulas to prove that the equations are correct. The equation of a vertical line is given as letter 1 d465 equals letter 1 d450, where c is a constant. The slope of a vertical line is undefined, and regardless of the y value of any point on the line, the x-coordinate of the point will be c. Suppose that we want to find the equation of a line containing the following points: minus 3, minus 5, minus 3, 1, minus 3, 3, and minus 3, 5. First, we will find the slope. Letter 1 d45a equals 5 minus 3 minus 3 minus 3 equals 20. 0 in the denominator means that the slope is undefined, and therefore, we cannot use the point slope formula. However, we can plot the points. Notice that all of the x-coordinates are the same, and we find a vertical line through letter 1 d465 equals minus 3. See figure 3. The equation of a horizontal line is given as letter 1 d466 equals letter 1 d450, where c is a constant. The slope of a horizontal line is 0, and for any x value of a point on the line, the y-coordinate will be c. Suppose we want to find the equation of a line that contains the following set of points: minus 2, 0, minus 2, 3, minus 2, and 5, minus 2. We can use the point slope formula. First, we find the slope using any 2 points on the line. Use any point for x1, y1 in the formula, or use the y-intercept. Letter 1d466 minus 2 letter 1d466 plus 2 letter 1d466 equals 0. Letter 1d465 minus 3, 0 minus 2, the graph is a horizontal line through letter 1d466 equals minus 2. Notice that all of the y-coordinates are the same. See Figure 3. Coordinate plane with the x-axis ranging from -7 to 4 and the y-axis ranging from -4 to 4. The function y -2 and the line x equals -3 are plotted. Figure 3, the line x equals -3 is a vertical line. The line y equals -2 is a horizontal line. Example 13, finding the equation of a line passing through the given points. Find the equation of the line passing through the given points. 1, -3, and 14. Solution: the x-coordinate of both points is 1. Therefore, we have a vertical line, letter 1d465 equals 1. Try at 10, find the equation of the line passing through -5, 2, and 22. Determining whether graphs of lines are parallel or perpendicular. Parallel lines have the same slope and different y-intercepts. Lines that are parallel to each other will never intersect. For example, Figure 4 shows the graphs of various lines with the same slope, letter 1d45a equals 2. Coordinate plane with the x-axis ranging from -8 to 8 in intervals of 2, and the y-axis ranging from -7 to 7. Three functions are graphed on the same plot. Y equals 2 times x minus 3, y equals 2 times x plus 1, and y equals 2 times x plus 5. Figure 4 parallel lines. All of the lines shown in the graph are parallel because they have the same slope and different y-intercepts. Lines that are perpendicular intersect to form a 90 degrees angle. The slope of one line is the negative reciprocal of the other. We can show that two lines are perpendicular if the product of the two slopes is -1. Letter 1d45a, 1 letter 1d45a, 2 equals -1. For example, Figure 5 shows the graph of two perpendicular lines. One line has a slope of 3, the other line has a slope of -13. Coordinate plane with the x-axis ranging from -3 to 6 and the y-axis ranging from -2 to 5. Two functions are graphed on the same plot. Y equals 3 times x minus 1 and y equals -x3 minus 2. Their intersection is marked by a box to show that it is a right angle. Figure 5 perpendicular lines. Example 14, graphing two equations and determining whether the lines are parallel, perpendicular, or neither. Graph the equations of the given lines and state whether they are parallel, perpendicular, or neither. 3 letter 1d466 equals -4 letter 1d465 plus 3, and 3 letter 1d465 minus 4 letter 1d466 equals 8. Solution: the first thing we want to do is rewrite the equations so that both equations are in slope-intercept form. First equation: 3 letter 1d466 letter 1d466 equals -4 letter 1d465 plus 3 minus 43 letter 1d465 plus 1. Second equation: 3 letter 1d465 minus 4 letter 1d466 minus 4 letter 1d466 letter 1d466 equals 8 minus 3 letter 1d465 plus 834 letter 1d465 minus 2. See the graph of both lines in Figure 6 coordinate plane, with the x-axis ranging from -4 to 5 and the y-axis ranging from -4 to 4. Two functions are graphed on the same plot. Y equals -4 times x3 plus 1 and y equals 3 times x4 minus 2. A box is placed at the intersection to note that it forms a right angle. Figure 6 from the graph, we can see that the lines appear perpendicular, but we must compare the slopes. The slopes are negative reciprocals of each other, confirming that the lines are perpendicular. Try at 11, graph the two lines and determine whether they are parallel, perpendicular, or neither. 2 letter 1d466 minus letter 1d465 equals 10, and 2 letter 1d466 equals letter 1d465 plus 4. Writing the equations of lines parallel or perpendicular to a given line as we have learned. Determining whether two lines are parallel or perpendicular is a matter of finding the slopes. To write the equation of a line parallel or perpendicular to another line, We follow the same principles as we do for finding the equation of any line. After finding the slope, use the point-slope formula to write the equation of the new line. How to given an equation for a line, write the equation of a line parallel or perpendicular to it. Find the slope of the given line. The easiest way to do this is to write the equation in slope-intercept form. Use the slope and the given point with the point-slope formula. Simplify the line to slope-intercept form and compare the equation to the given line. Example 15, writing the equation of a line parallel to a given line, passing through a given point, write the equation of line parallel to a 5-letter 1d465 plus 3-letter 1d466 equals 1, and passing through the point, 35. Solution first, we will write the equation in slope-intercept form to find the slope. 5-letter 1d465 plus 3-letter 1d466, 3-letter 1d466 letter 1d466 equals 1 5-letter 1d465 plus 1 minus 53 letter 1d465 plus 13. The slope is letter 1d45a equals minus 53. The y-intercept is 13, but that really does not enter into our problem, as the only thing we need for two lines to be parallel is the same slope. The one exception is that if the y-intercepts are the same, then the two lines are the same line. The next step is to use this slope and the given point with the point-slope formula. Letter 1d466 minus 5 letter 1d466 minus 5 letter 1d466 equals minus 53. Letter 1d465 minus 3. Minus 53 letter 1d465 plus 5 minus 53 letter 1d465 plus 10. The equation of the line is letter 1d466 equals minus 53 letter 1d465 plus 10. See Figure 7. Coordinate plane with the x-axis ranging from -8 to 8 in intervals of 2, and the y-axis ranging from -2 to 12 in intervals of 2. Two functions are graphed on the same plot. Y equals -5 times x3 plus 1 3, and y equals -5 times x3 plus 10. The lines do not cross. Figure 7. Try at 12. Find the equation of the line parallel to 5 letter 1d465 equals 7 plus letter 1d466, and passing through the point, -1, -2. Example 16. Finding the equation of a line perpendicular to a given line passing through a given point, find the equation of the line perpendicular to 5 letter 1d465 minus 3 letter 1d466 plus 4 equals 0, and passing through the point, -4, 1. Solution. The first step is to write the equation in slope-intercept form. 5 letter 1d465 minus 3 letter 1d466 plus 4 minus 3 letter 1d466 letter 1d466 equals 0 minus 5 letter 1d465 minus 453 letter 1d465 plus 43. We see that the slope is letter 1d45a equals 53. This means that the slope of the line perpendicular to the given line is the negative reciprocal, or minus 35. Next, we use the point-slope formula with this new slope and the given point. Letter 1d466 minus 1 letter 1d466 minus 1 letter 1d466 letter 1d466 equals minus 35. Letter 1d465 minus 4. Minus 35 letter 1d465 minus 125 minus 35 letter 1d465 minus 125 plus 55 minus 35 letter 1d465 minus 75. Media access these online resources for additional instruction and practice with linear equations, solving rational equations, equation of a line given 2 points, finding the equation of a line perpendicular to another line through a given point, finding the equation of a line parallel to another line through a given point 2. 2-section exercises. Verbal 1. What does it mean when we say that two lines are parallel? 2. What is the relationship between the slopes of perpendicular lines, assuming neither is horizontal nor vertical? 3. How do we recognize when an equation, for example letter 1d466 equals 4 letter 1d465 plus 3, will be a straight line, linear, when graphed? 4. What does it mean when we say that a linear equation is inconsistent? 5. When solving the following equation, 2 letter 1d465 minus 5 equals 4 letter 1d465 plus 1, explain why we must exclude letter 1d465 equals 5 and letter 1d465 equals -1 as possible solutions from the solution set. Algebraic for the following exercises, solve the equation for x6. 7 letter 1d465 plus 2 equals 3 letter 1d465 minus 9 7. 4 letter 1d465 minus 3 equals 5 8. 3 letter 1d465 plus 2 minus 12 equals 5. Letter 1d465 plus 1 9. 12 minus 5 letter 1d465 plus 3 equals 2 letter 1d465 minus 5 10. 12 minus 13 letter 1d465 equals 43 11. Letter 1d465 3 minus 34 equals 2 letter 1d465 plus 312 12. 23 letter 1d465 plus 12 equals 316 13. 3 2 letter 1d465 minus 1 plus letter 1d465 equals 5 letter 1d465 plus 314. 2 letter 1d465 3 minus 34 equals letter 1d465 6 plus 214 15. Letter 1d465 plus 24 minus letter 1d465 minus 13 equals 2 for the following exercises. Solve each rational equation for x. State all x values that are excluded from the solution set. 16. 3 letter 1d465 minus 13 equals 16 17. 2 minus 3 letter 1d465 plus 4 equals letter 1d465 plus 2 letter 1d465 plus 4 18. 3 letter 1d465 minus 2 equals 1 letter 1d465 minus 1 plus 7. Letter 1d465 minus 1. Letter 1d465 minus 2, 19. 3 letter 1d465 letter 1d465 minus 1 plus 2 equals 3 letter 1d465 minus 120. 5 letter 1d465 plus 1 letter 1d465 minus 3 equals minus 6 letter 1d465 2 minus 2 letter 1d465 minus 321. 1 letter 1d465 equals 15 plus 32 letter 1d465 for the following exercises. Find the equation of the line using the point-slope formula. Write all the final equations using the slope-intercept form. 22, 3 with a slope of 23 23, 12 with a slope of minus 45 24. X-intercept is 1 and minus 2 6 25. Y-intercept is 2 and 4 minus 1 26. Minus 3 10 and 5 minus 6 27. 13 and 55 28. Parallel to letter 1d466 equals 2 letter 1d465 plus 5 and passes through the point 43 29. Perpendicular to 3 letter 1d466 equals letter 1d465 minus 4 and passes through the point minus 2 1. For the following exercises, find the equation of the line using the given information. 30, minus 2 0 and minus 2 5 31, 17 and 37 32. The slope is undefined and it passes through the point 23 33. The slope equals 0 and it passes through the point 1 minus 4 34. The slope is 34 and it passes through the point 14 35. 13 and 4 5 graphical for the following exercises. Graph the pair of equations on the same axes and state whether they are parallel, perpendicular, or neither. 36. Letter 1d466 equals 2 letter 1d465 plus 7 letter 1d466 equals minus 12 letter 1d465 minus 437. 3 letter 1d465 minus 2 letter 1d466 equals 56 letter 1d466 minus 9 letter 1d465 equals 638. Letter 1d466 equals 3 letter 1d465 plus 14 letter 1d466 equals 3 letter 1d465 plus 239. Letter 1d465 equals 4 letter 1d466 equals minus 3 numeric for the following exercises. Find the slope of the line that passes through the given points. 40, 54 and 79 41, minus 3 2 and 4 minus 7 42, minus 5 4 and 24 43, minus 1 minus 2 and 34 44, 3 minus 2 and 3 minus 2 for the following exercises. Find the slope of the lines that pass through each pair of points and determine whether the lines are parallel or perpendicular. 45. Minus 1, 3, and 5, 1, minus 2, 3, and 9, 46. 25 and 5, 9, minus 1, and 23 technology for the following exercises express the equations in slope-intercept form, rounding each number to the thousandths place. Enter this into a graphing calculator as y1, then adjust the immin and immax values for your window to include where the y-intercept occurs. State your immin and immax values. 47, 0. 537 letter 1d465 minus 2. 19 letter 1d466 equals 148. 4. 500 letter 1d465 minus 200 letter 1d466 equals 9. 528.49. 200 minus 30 letter 1d466 letter 1d465 equals 70 extensions 50. Starting with the point slope formula, letter 1d466 minus letter 1d466, 1 equals letter 1d45a. Letter 1d465 minus letter 1d465, 1. Solve this expression for x in terms of x1, y1, and m. 51. Starting with the standard form of an equation, letter 1d434 letter 1d465 plus letter 1d435 letter 1d466 equals letter 1d436, solve this expression for y in terms of a, b, c, and x. Then put the expression in slope-intercept form. 52. Use the above derived formula to put the following standard equation in slope-intercept form. 7 letter 1d465 minus 5 letter 1d466 equals 25. 53. Given that the following coordinates are the vertices of a rectangle, prove that this truly is a rectangle by showing the slopes of the sides that meet are perpendicular. 1, 1, 2, 0, 3, 3, and 4, 54. Find the slopes of the diagonals in the previous exercise. Are they perpendicular? Real-world applications 55. The slope for a wheelchair ramp for a home has to be 112. If the vertical distance from the ground to the door bottom is 25 ft, find the distance the ramp has to extend from the home in order to comply with the needed slope. 56. If the profit equation for a small business selling X number of item 1 and Y number of item 2 is letter 1d45d equals 3 letter 1d465 plus 4 letter 1d466. Find the Y value when letter 1d45d equals $453 and letter 1d465 equals 75. For the following exercises, use this scenario. The cost of renting a car is $45/WK plus $0. $25 me traveled during that week. An equation to represent the cost would be letter 1d466 equals 45 plus 25x, where x is the number of miles traveled. 57. What is your cost if you travel 50 mi? 58. If your cost were $63. $75, how many miles were you charged for traveling? 59. Suppose you have a maximum of $100 to spend for the car rental. What would be the maximum number of miles you could travel? Learning objectives in this section, you will set up a linear equation to solve a real-world application. Use a formula to solve a real-world application. Many students studying in a large lecture hall figure 1 credit. Kevin Dooley Necka is hoping to get an A in his college algebra class. He has scores of 75, 82, 95, 91, and 94 on his first 5 tests. Only the final exam remains, and the maximum number of points that can be earned is 100. Is it possible for Necka to end the course with an A? A simple linear equation will give Necka his answer. Many real-world applications can be modeled by linear equations. For example, a cell phone package may include a monthly service fee plus a charge per minute of talk time. It costs a widget manufacturer a certain amount to produce X widgets per month plus monthly operating charges. A car rental company charges a daily fee plus an amount per mile driven. These are examples of applications we come across every day that are modeled by linear equations. In this section, we will set up and use linear equations to solve such problems. Setting up a linear equation to solve a real-world application to set up or model a linear equation to fit a real-world application. We must first determine the known quantities and define the unknown quantity as a variable. Then, we begin to interpret the words as mathematical expressions using mathematical symbols. Let us use the car rental example above. In this case, a known cost, such as $0, 10 mi, is multiplied by an unknown quantity, the number of miles driven. Therefore, we can write 0. 10x. This expression represents a variable cost because it changes according to the number of miles driven. If a quantity is independent of a variable, we usually just add or subtract it, according to the problem. As these amounts do not change, we call them fixed costs. Consider a car rental agency that charges $0, 10 mi plus a daily fee of $50. We can use these quantities to model an equation that can be used to find the daily car rental cost. See letter 1D436 equals 0. 10x plus 50. When dealing with real-world applications, there are certain expressions that we can translate directly into math. Table 1 lists some common verbal expressions and their equivalent mathematical expressions. Verbal translation to math operations: one number exceeds another by a x. X plus a twice a number 2x one number is a more than another number x. X plus a one number is a less than twice another number x. 2 letter 1D465 minus letter 1D44e, the product of a number, and a. Decreased by b letter 1D44 letter 1D465 minus letter 1D44f, the quotient of a number, and the number plus, is 3 times the number letter 1D465 letter 1D465 plus letter 1D44e equals 3 letter 1D465, the product of 3 times a number, and the number decreased by b is c 3 letter 1D465. Letter 1D465 minus letter 1D44f equals letter 1D450, Table 1. How to given a real-world problem. Model a linear equation to fit it. Identify known quantities. Assign a variable to represent the unknown quantity. If there is more than one unknown quantity, find a way to write the second unknown in terms of the first. Write an equation interpreting the words as mathematical operations. Solve the equation. Be sure the solution can be explained in words, including the units of measure. Example 1, modeling a linear equation to solve an unknown number problem. Find a linear equation to solve for the following unknown quantities. One number exceeds another number by 17, and their sum is 31. Find the two numbers. Solution: let x equal the first number. Then, as the second number exceeds the first by 17, we can write the second number as x plus 17. The sum of the two numbers is 31. We usually interpret the word is as an equal sign. Letter 1D465 plus. Letter 1D465 plus 17. 2 letter 1D465 plus 172 letter 1D465 letter 1D465 letter 1D465 plus 17 equals 3,131. Simplify and solve. 1477 plus 1724, the two numbers are 7 and 24. Try it 1. Find a linear equation to solve for the following unknown quantities. One number is 3 more than twice another number. If the sum of the two numbers is 36, find the numbers. Example 2, setting up a linear equation to solve a real-world application. There are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus $5 min talk time. Company B charges a monthly service fee of $40 plus $4 min talk time. Write a linear equation that models the packages offered by both companies. B. If the average number of minutes used each month is 1,160, which company offers the better plan? C. If the average number of minutes used each month is 420, which company offers the better plan? D. How many minutes of talk time would yield equal monthly statements from both companies? Solution: A. The model for Company A can be written as letter 1D434 equals 0. 5x plus 34. This includes the variable cost of 0. 5x plus the monthly service charge of $34. Company B's package charges a higher monthly fee of $40, but a lower variable cost of 0. 4x. Company B's model can be written as letter 1D435 equals 0. 4 letter 1D465 plus $40. B. If the average number of minutes used each month is 1,160, we have the following. Company A company, letter 1D435 equals 0. 0, 5, 1, 160, plus 3,458 plus 34,920. 0, 4, 1, 160, plus 4,046. 4 plus 40, 86. For so, Company B offers the lower monthly cost of $86. $40 as compared with the $92 monthly cost offered by Company A when the average number of minutes used each month is 1,160. See if the average number of minutes used each month is 420, we have the following. Company A Company, letter 1D435 = 0, plus 34550, 8 plus 4056, 8 if the average number of minutes used each month is 420, then Company A offers a lower monthly cost of $55 compared to Company B's monthly cost of $56. $80. D. To answer the question of how many talk time minutes would yield the same bill from both companies, we should think about the problem in terms of XY coordinates. At what point are both the X value and the Y value equal? We can find this point by setting the equations equal to each other and solving for x0. 5x plus 340. 0, 1, letter 1D465, letter 1D465 = 0. 4x plus 406600, check the x value in each equation. 0. 0, 5, 600, plus 340. 0, 4, 600, plus 40 = 6,464. Therefore, a monthly average of 600 talk time minutes renders the plans equal. See Figure 2 coordinate plane with the x-axis ranging from 0 to 1200 in intervals of 100, and the y-axis ranging from 0 to 90 in intervals of 10. The functions a equals 0, 5x plus 34 and b equals 0, 4x plus 40, are graphed on the same plot. Figure 2. Try it 2. Find a linear equation to model this real-world application. It costs ABC Electronics Company $2. $50 per unit to produce a part used in a popular brand of desktop computers. The company has monthly operating expenses of $350 for utilities and $3,300 for salaries. What are the company's monthly expenses? Using a formula to solve a real-world application, many applications are solved using known formulas. The problem is stated, a formula is identified, the known quantities are substituted into the formula, the equation is solved for the unknown, and the problem's question is answered. Typically, these problems involve two equations representing two trips, two investments, two areas, and so on. Examples of formulas include the area of a rectangular region, letter 1D434 equals letter 1D43F letter 1D44A. The perimeter of a rectangle, letter 1D443, equals 2 letter 1D43F plus 2 letter 1D44A. And the volume of a rectangular solid, letter 1D449, equals letter 1D43F letter 1D44A letter 1D43B. When there are two unknowns, we find a way to write one in terms of the other, because we can solve for only one variable at a time. Example 3. Solving an application using a formula, it takes Andrew 30 min to drive to work in the morning. He drives home using the same route, but it takes 10 min longer, and he averages 10 mph less than in the morning. How far does Andrew drive to work? Solution: this is a distance problem, so we can use the formula letter 1D451 equals letter 1D45F letter 1D461, where distance equals rate multiplied by time. Note that when rate is given in mph, time must be expressed in hours. Consistent units of measurement are key to obtaining a correct solution. First, we identify the known and unknown quantities. Andrew's morning drive to work takes 30 min, or 12h at rate r. His drive home takes 40 min, or 23h, and his speed averages 10 mph less than the morning drive. Both trips cover distance d. A table, such as Table 2, is often helpful for keeping track of information in these types of problems. DRT to work DR12, to home D letter 1D45F minus 1023. Table 2. Write two equations, one for each trip. Letter 1D451 letter 1D451 equals letter 1D45F 12, letter 1D45F minus 10 23. To work to home, as both equations equal the same distance, we set them equal to each other and solve for r. Letter 1D45F 12 12 letter 1d45f, 12 letter 1d45f, minus 23 letter 1d45f, minus 16 letter 1d45f, letter 1d45f, letter 1d45f equals. Letter 1d45f minus 10. 23 letter 1d45f minus 203 minus 203 minus 203 minus 203. Minus 6. 40. We have solved for the rate of speed to work. 40 mph. Substituting 40 into the rate on the return trip yields 30 mph. Now we can answer the question. Substitute the rate back into either equation and solve for d. Letter 1d451 equals 40, 12, 20. The distance between home and work is 20 mph. Analysis. Note that we could have cleared the fractions in the equation by multiplying both sides of the equation by the LCD to solve for r. Letter 1d45f, 12, 6 times letter 1d45f, 12's 3 letter 1d45f, 3 letter 1d45f minus letter 1d45f, letter 1d45f equals. Letter 1d45f minus 10. 23 6 times, letter 1d45f minus 10. 23 4. Letter 1d45f minus 10 4 letter 1d45f minus 40 minus 4040. Try it 3 on Saturday morning. It took Jennifer 3:06 to drive to her mother's house for the weekend. On Sunday evening, due to heavy traffic, it took Jennifer 4:00 to return home. Her speed was 5 mph slower on Sunday than on Saturday. What was her speed on Sunday? Example 4. Solving a perimeter problem. The perimeter of a rectangular outdoor patio is 54 ft. The length is 3 ft greater than the width. What are the dimensions of the patio? Solution. The perimeter formula is standard. Letter 1d443 equals 2 letter 1d43f plus 2 letter 1d44a. We have two unknown quantities, length and width. However, we can write the length in terms of the width as letter 1d43f equals letter 1d44a plus 3. Substitute the perimeter value and the expression for length into the formula. It is often helpful to make a sketch and label the sides as in Figure 3. A rectangle with the length labeled as L equals w plus 3 and the width labeled as w. Figure 3. Now we can solve for the width and then calculate the length. Letter 1d443, 5,454,540,4,812. 12 plus 3, 15 equals 2 letter 1d43f plus 2 letter 1d44a 2, letter 1d44a plus 3, plus 2 letter 1d44a to w, plus 6 plus 2w 4w plus 64 wwll. The dimensions are letter 1d43f equals 15 ft and letter 1d44a equals 12 ft. Try it 4. Find the dimensions of a rectangle given that the perimeter is 110 cm and the length is 1 cm more than twice the width. Example 5. Solving an area problem. The perimeter of a tablet of graph paper is 48 in. The length is 6 in, more than the width. Find the area of the graph paper. Solution. The standard formula for area is letter 1d434 equals letter 1d43f, letter 1d44a. However, we will solve the problem using the perimeter formula. The reason we use the perimeter formula is because we know enough information about the perimeter that the formula will allow us to solve for one of the unknowns. As both perimeter and area use length and width as dimensions, they are often used together to solve a problem such as this one. We know that the length is 6 in, more than the width, so we can write length as letter 1d43f equals letter 1d44a plus 6. Substitute the value of the perimeter and the expression for length into the perimeter formula and find the length. Letter 1d443 480 4,840 8,369 9 plus 6. 15 equals 2 letter 1d43f plus 2 letter 1d44a 2, letter 1d44a plus 6. Plus 2 letter 1d44a to w plus 12 plus 2w 4w plus 124 wwll. Now we find the area given the dimensions of letter 1d43f equals 15 in and letter 1d44a equals 9 in. Letter 1d434 letter 1d434 equals letter 1d43f letter 1d44a 15 9 135 in. 2. The area is 135 in. 2. Try it 5. A game room has a perimeter of 70 ft. The length is 5 more than twice the width. How many ft2 of new carpeting should be ordered? Example 6, solving a volume problem, find the dimensions of a shipping box, given that the length is twice the width, the height is 8 inches, and the volume is 1,600 in. 3. Solution, the formula for the volume of a box, is given as letter 1d449 equals letter 1d43f, letter 1d44a, letter 1d43b. The product of length, width, and height. We are given that letter 1d43f equals 2 letter 1d44a, and letter 1d43b equals 8. The volume is 1,600 cubic inches. V1, 6,001. The dimensions are letter 1d43f equals 20 in, letter 1d44a equals 10 in, and letter 1d43b equals 8 in. Analysis, note that the square root of W2 would result in a positive and a negative value. However, because we are describing width, we can use only the positive result. Media access these online resources for additional instruction and practice with models and applications of linear equations. Problem solving using linear equations, problem solving using equations, finding the dimensions of area given the perimeter, find the distance between the cities using the distance equals rate time formula linear equation application. Write a cost equation. 2. 3-section exercises verbal 1. To set up a model linear equation to fit real-world applications, what should always be the first step? 2. Use your own words to describe this equation, where n is a number. 5. Letter 1d45b plus 3 equals 2 letter 1d45b3. If the total amount of money you had to invest was $2,000 and you deposit X amount in one investment, how can you represent the remaining amount? 4. If a carpenter sawed a 10 ft board into 2 sections, and one section was n ft long, how long would the other section be in terms of letter 1d45b? 5. If Bill was traveling v-h, how would you represent Demon's speed if he was traveling 10 mph faster? Real-world applications for the following exercises use the information to find a linear algebraic equation model to use to answer the question being asked. 6. Mark and Don are planning to sell each of their marble collections at a garage sale. If Don has won more than 3 times the number of marbles Mark has, how many does each boy have to sell if the total number of marbles is 113? 7. Bate and Ann are joking that their combined ages equal Sam's age. If Bate is twice Ann's age and Sam is 69 or old, what are Bate and Ann's ages? 8. Rudin originally filled out 8 more applications than Han. Then each boy filled out 3 additional applications, bringing the total to 28. How many applications did each boy originally fill out? For the following exercises, use this scenario. 2 different telephone carriers offer the following plans that a person is considering. Company A has a monthly fee of $20 and charges of $5 min for calls. Company B has a monthly fee of $5 and charges $10 min for calls. 9. Find the model of the total cost of Company A's plan using M for the minutes. 10. Find the model of the total cost of Company B's plan using M for the minutes. 11. Find out how many minutes of calling would make the 2 plans equal. 12. If the person makes a monthly average of 200 min of calls, which plan should for the person choose? For the following exercises, use this scenario. A wireless carrier offers the following plans that a person is considering. The family plan, $90 monthly fee, unlimited talk and text on up to 8 lines, and data charges of $40 for each device for up to 2 GB of data per device. The mobile share plan, $120 monthly fee for up to 10 devices, unlimited talk and text for all the lines, and data charges of $35 for each device up to a shared total of 10 GB of data. Use P for the number of devices that need data plans as part of their cost. 13. Find the model of the total cost of the family plan. 14. Find the model of the total cost of the mobile share plan. 15. Assuming they stay under their data limit, find the number of devices that would make the 2 plans equal in cost. 16. If a family has 3 smartphones, which plan should they choose? For exercises 17 and 18, use this scenario. A retired woman has $50,000 to invest, but needs to make $6,000 a year from the interest to meet certain living expenses. One bond investment pays 15% annual interest. The rest of it she wants to put in a CD that pays 7%. 17. If we let X be the amount the woman invests in the 15% bond, how much will she be able to invest in the CD? 18. Set up and solve the equation for how much the woman should invest in each option to sustain a $6,000 annual return. 19. Two planes fly in opposite directions. One travels 450 mph and the other 550 mph. How long will it take before they are 4,000 mph apart? 20. Ben starts walking along a path at 4 mph. 1.5 hours after Ben leaves, his sister Amanda begins jogging along the same path at 6 mph. How long will it be before Amanda catches up to Ben? 21. Fiora starts riding her bike at 20 mph. After a while, she slows down to 12 mph and maintains that speed for the rest of the trip. The whole trip of 70 mph takes her 4-5 h. For what distance did she travel at 20 mph? 22. A chemistry teacher needs to mix a 30% salt solution with a 70% salt solution to make 20 qt of a 40% salt solution. How many quarts of each solution should the teacher mix to get the desired result? 23. Raul has $20,000 to invest. His intent is to earn 11% interest on his investment. He can invest part of his money at 8% interest and part at 12% interest. How much does Raul need to invest in each option to get a total 11% return on his $20,000? For the following exercises, use this scenario. A truck rental agency offers two kinds of plans. Plan A charges 75/WK plus 10 mi driven. Plan B charges 100/WK plus $5 mi driven. 24. Write the model equation for the cost of renting a truck with Plan A 25. Write the model equation for the cost of renting a truck with Plan B 26. Find the number of miles that would generate the same cost for both plans. 27. If Tim knows he has to travel 300 mph, which plan should he choose? For the following exercises, use the formula given to solve for the required value. 28. Letter 1D434 equals letter 1D443. 1 plus letter 1D45F letter 1D461 is used to find the principal amount P deposited, earning R% interest for T years. Use this to find what principal amount P David invested at a 3% rate for 20, or if letter 1D434 equals $8,000. 29. The formula letter 1D439 equals letter 1D45A letter 1D463 to R relates force F, velocity V, mass, and resistance M. Find R when letter 1D45A equals 45, letter 1D463 equals 7, and letter 1D439 equals 245. 30. Letter 1D439 equals letter 1D45A letter 1D440 indicates that force F equals mass M times acceleration A. Find the acceleration of a mass of 50 kg if a force of 12 N is exerted on it. 31. Letter 1D446 letter 1D462 letter 1D45A equals 11 minus letter 1D45F is the formula for an infinite series sum. If the sum is 5, find R. For the following exercises, solve for the given variable in the formula. After obtaining a new version of the formula, you will use it to solve a question. 32. Solve for W. Letter 1D443 equals 2 letter 1D43F plus 2 letter 1D44A 33. Use the formula from the previous question to find the width, W, of a rectangle whose length is 15 and whose perimeter is 58. 34. Solve for F. 1 letter 1D45D plus 1 letter 1D45E equals 1 letter 1D453 35. Use the formula from the previous question to find F when letter 1D45D equals 8 and letter 1D45E equals 13. 36. Solve for M in the slope-intercept formula. Letter 1D466 equals letter 1D45A letter 1D465 plus letter 1D44F 37. Use the formula from the previous question to find M when the coordinates of the point are 47 and letter 1D44F equals 12. 38. The area of a trapezoid is given by letter 1D434 equals 12 letter 210E. Letter 1D44F 1 plus letter 1D44F2. Use the formula to find the area of a trapezoid with letter 210e equals 6, letter 1d44f1 equals 14, and letter 1d44f2 equals 8. 39. Solve for h. Letter 1d434 equals 12 letter 210e. Letter 1d44f1 plus letter 1d44f2 40. Use the formula from the previous question to find the height of a trapezoid with letter 1d434 equals 150, letter 1d44f1 equals 19, and letter 1d44f2 equals 11. 41. Find the dimensions of an American football field. The length is 200 ft more than the width, and the perimeter is 1040 ft. Find the length and width. Use the perimeter formula letter 1d443 equals 2 letter 1d43f plus 2 letter 1d44a. 42. Distance equals rate times time. Letter 1d451 equals letter 1d45f letter 1d461. Find the distance Tom travels if he is moving at a rate of 55 mph for 35h43. Using the formula in the previous exercise, find the distance that Susan travels if she is moving at a rate of 60 mph for 75h44. What is the total distance that two people travel in 3h if one of them is riding a bike at 15 mph and the other is walking at 3 mph? 45. If the area model for a triangle is letter 1d434 equals 12 letter 1d44f letter 210e, find the area of a triangle with a height of 16 in and a base of 11 in. 46. Solve for h. Letter 1d434 equals 12 letter 1d44f letter 210e, 47. Use the formula from the previous question to find the height to the nearest tenth of a triangle with a base of 15 and an area of 215. 48. The volume formula for a cylinder is letter 1d449 equals letter 1d70b letter 1d45f to 8. Using the symbol letter 1d70b in your answer, find the volume of a cylinder with a radius, r, of 4 cm and a height of 14 cm. 49. Solve for h. Letter 1d449 equals letter 1d70b letter 1d45f to h 50. Use the formula from the previous question to find the height of a cylinder with a radius of 8 and a volume of 16 letter 1d70b 51. Solve for r. Letter 1d449 equals letter 1d70b letter 1d45f to h 52. Use the formula from the previous question to find the radius of a cylinder with a height of 36 and a volume of 324 letter 1d70b. 53. The formula for the circumference of a circle is letter 1d436 equals 2 letter 1d70b letter 1d45f. Find the circumference of a circle with a diameter of 12 in. Diameter equals 2r. Use the symbol letter 1d70b in your final answer. 54. Solve the formula from the previous question for letter 1d70b. Notice why letter 1d70b is sometimes defined as the ratio of the circumference to its diameter. Learning objectives. In this section, you will solve quadratic equations by factoring, solve quadratic equations by the square root property, solve quadratic equations by completing the square, solve quadratic equations by using the quadratic formula. Two televisions side by side. The right television is slightly larger than the left. Figure 1. The computer monitor on the left in Figure 1 is a 23.6-inch model, and the one on the right is a 27-inch model. Proportionally, the monitors appear very similar. If there is a limited amount of space and we desire the largest monitor possible, how do we decide which one to choose? In this section, we will learn how to solve problems such as this using 4 different methods. Solving quadratic equations by factoring. An equation containing a second-degree polynomial is called a quadratic equation. For example, equations such as 2 letter 1d4652 plus 3 letter 1d465 minus 1 equals 0, and letter 1d465 2 minus 4 equals 0 are quadratic equations. They are used in countless ways in the fields of engineering, architecture, finance, biological science, and, of course, mathematics. Often the easiest method of solving a quadratic equation is factoring. Factoring means finding expressions that can be multiplied together to give the expression on one side of the equation. If a quadratic equation can be factored, it is written as a product of linear terms. Solving by factoring depends on the zero product property, which states that if letter 1d44e letter 1d44f equals 0, then letter 1d44e equals 0, or letter 1d44f equals 0, wherein b are real numbers or algebraic expressions. In other words, if the product of two numbers or two expressions equals 0, then one of the numbers or one of the expressions must equal 0, because 0 multiplied by anything equals 0. Multiplying the factors expands the equation to a string of terms separated by plus or minus signs. So, in that sense, the operation of multiplication undoes the operation of factoring. For example, expand the factored expression, letter 1d465 minus 2, letter 1d465 plus 3, by multiplying the two factors together, letter 1d465 minus 2, letter 1d465 plus 3 equals letter 1d465 2, plus 3 letter 1d465 minus 2 letter 1d465 minus 6 letter 1d465 2, plus letter 1d465 minus 6. The product is a quadratic expression. Set equal to 0, letter 1d465 2 plus letter 1d465 minus 6 equals 0. Is a quadratic equation. If we were to factor the equation, we would get back the factors we multiplied. The process of factoring a quadratic equation depends on the leading coefficient, whether it is one or another integer. We will look at both situations, but first, we want to confirm that the equation is written in standard form. Letter 1d44 letter 1d465, 2, plus letter 1d44f letter 1d465, plus letter 1d450 equals 0. Where b and c are real numbers, and letter 1d44e not equal to 0. The equation letter 1d465, 2 plus letter 1d465, minus 6 equals 0, is in standard form. We can use the zero product property to solve quadratic equations in which we first have to factor out the greatest common factor, GCF. And for equations that have special factoring formulas as well, such as the difference of squares, both of which we will see later in this section. The zero product property and quadratic equations. The zero product property states, if letter 1d44e, letter 1d44f equals 0, then, or letter 1d44f equals 0, wherein b are real numbers or algebraic expressions. A quadratic equation is an equation containing a second-degree polynomial. For example, letter 1d44e, letter 1d465, 2, plus letter 1d44f letter 1d465 plus letter 1d450 equals 0, where b and c are real numbers, and if letter 1d44e not equal to 0, it is in standard form, solving quadratics with a leading coefficient of 1. In the quadratic equation, letter 1d465, 2, plus letter 1d465 minus 6 equals 0. The leading coefficient, or the coefficient of letter 1d465, 2, is 1. We have one method of factoring quadratic equations in this form. How to? Given a quadratic equation with the leading coefficient of 1, factor it. Find two numbers whose product equals c and whose sum equals b. Use those numbers to write two factors of the form, letter 1d465 plus letter 1d458, or letter 1d465 minus letter 1d458, where k is one of the numbers found in step 1. Use the numbers exactly as they are. In other words, if the two numbers are 1 and minus 2, the factors are letter 1d465 plus 1, letter 1d465 minus 2. Solve using the zero product property by setting each factor equal to 0 and solving for the variable. Example 1. Factoring and solving a quadratic with leading coefficient of 1. Factor and solve the equation. Letter 1d465 2 plus letter 1d465 minus 6 equals 0. Solution. To factor letter 1d465, 2 plus letter 1d465 minus 6 equals 0, we look for two numbers whose product equals minus 6 and whose sum equals 1. Begin by looking at the possible factors of minus 6. 1 minus 6, minus 6, 12 minus 3, 3 minus 2. The last pair, 3 minus 2, sums to 1, so these are the numbers. Note that only one pair of numbers will work. Then, write the factors. Letter 1d465 minus 2, letter 1d465 plus 3 equals 0. To solve this equation, we use the zero product property. Set each factor equal to 0 and solve. Letter 1 d465 minus 2, letter 1 d465 plus 3, letter 1 d465 minus 2, letter 1 d465, letter 1 d465 plus 3, letter 1 d465 equals 0, 0, 2, 0 minus 3. The two solutions are 2 and minus 3. We can see how the solutions relate to the graph in figure 2. The solutions are the x-intercepts of letter 1 d466 equals letter 1 d465, 2 plus letter 1 d465 minus 6 equals 0. Coordinate plane with the x-axis ranging from -5 to 5 and the y-axis ranging from -7 to 7. The function x squared plus x minus 6 equals 0 is graphed, with the x-intercepts, minus 30 and 20, plotted as well. Figure 2. Try it 1. Factor and solve the quadratic equation. Letter 1 d465 2 minus 5, letter 1 d465 minus 6 equals 0. Example 2. Solve the quadratic equation by factoring. Solve the quadratic equation by factoring. Letter 1 d465 2 plus 8 letter 1 d465 plus 15 equals 0. Solution. Find two numbers whose product equals 15 and whose sum equals 8. List the factors of 15. 153 5 minus 1, minus 15, minus 3, minus 5. The numbers that add to 8 are 3 and 5. Then, write the factors. Set each factor equal to 0, and solve. Letter 1 d465 plus 3, letter 1 d465 plus 5. Letter 1 d465 plus 3, letter 1 d465. Letter 1 d465 plus 5, letter 1 d465 equals 0, 0 minus 30 minus 5. The solutions are minus 3 and minus 5. Try it 2. Solve the quadratic equation by factoring. Letter 1 d465 2 minus 4, letter 1 d465 minus 21 equals 0. Example 3. Using the zero product property to solve a quadratic equation written as the difference of squares. Solve the difference of squares equation using the zero product property. Letter 1 d465 2 minus 9 equals 0. Solution. Recognizing that the equation represents the difference of squares, we can write the two factors by taking the square root of each term, using a minus sign as the operator in one factor and a plus sign as the operator in the other. Solve using the zero factor property. Letter 1 d465 2 minus 9, letter 1 d465 minus 3. Letter 1 d465 plus 3. Letter 1 d465 minus 3, letter 1 d465. Letter 1 d465 plus 3. Letter 1 d465 equals 0, 0, 0, 3, 0 minus 3. The solutions are 3 and minus 3. Try it 3. Solve by factoring. Letter 1 d465 2 minus 25 equals 0. Solving a quadratic equation by factoring when the leading coefficient is not 1. When the leading coefficient is not 1, we factor a quadratic equation using the method called grouping, which requires 4 terms. With the equation in standard form, let's review the grouping procedures. With the quadratic in standard form, letter 1 d44 letter 1 d465 2 plus letter 1 d44f letter 1 d465 plus letter 1 d450 equals 0. Multiply letter 1 d44 letter 1 d450. Find two numbers whose product equals letter 1 d44 letter 1 d450 and whose sum equals letter 1 d44f. Rewrite the equation, replacing the letter 1 d44f letter 1 d465 term with two terms using the numbers found in step 2 as coefficients of x. Factor the first two terms and then factor the last two terms. The expressions in parentheses must be exactly the same to use grouping. Factor out the expression in parentheses. Set the expressions equal to 0 and solve for the variable. Example 4. Solving a quadratic equation using grouping. Use grouping to factor and solve the quadratic equation. 4 letter 1 d465 2 plus 15 letter 1 d465 plus 9 equals 0. Solution. First, multiply letter 1 d44 letter 1 d450. 4, 9 equals 36. Then list the factors of 36. 1 362 180, 3 124 96 6. The only pair of factors that sums to 15 is 3 plus 12. Rewrite the equation replacing the b term, 15 letter 1 d465, with two terms using 3 and 12 as coefficients of x. Factor the first two terms and then factor the last two terms. 4 letter 1d4652 plus 3 letter 1d465 plus 12 letter 1d465 plus 9 letter 1d465. 4 letter 1d465 plus 3 plus 3, 4 letter 1d465 plus 3, 4 letter 1d465 plus 3, letter 1d465 plus 3 equals 0, 0, 0. Solve using the zero product property. 4 letter 1d465 plus 3, letter 1d465 plus 3, 4 letter 1d465 plus 3 letter 1d465, letter 1d465 plus 3, letter 1d465 equals 0, 0 minus 340 minus 3. The solutions are minus 34 and minus 3. See Figure 3. Coordinate plane with the x-axis ranging from -6 to 2 with every other tick mark labeled, and the y-axis ranging from -6 to 2 with each tick mark numbered. The equation 4x squared plus 15x plus 9 is graphed with its x-intercepts, minus 340 and plotted as well. Figure 3. Try it 4. Solve using factoring by grouping. 12 letter 1d465 2 plus 11 letter 1d465 plus 2 equals 0. Example 5. Solving a polynomial of higher degree by factoring. Solve the equation by factoring. Minus 3 letter 1d465, 3 minus 5 letter 1d465, 2 minus 2 letter 1d465 equals 0. Solution. This equation does not look like a quadratic, as the highest power is 3, not 2. Recall that the first thing we want to do when solving any equation is to factor out the GCF, if one exists, and it does here. We can factor out minus letter 1d465 from all of the terms and then proceed with grouping. Minus 3 letter 1d465, 3 minus 5 letter 1d465, 2 minus 2 letter 1d465, minus letter 1d465. 3 letter 1d465 2 plus 5 letter 1d465 plus 2 equals 0, 0. Use grouping on the expression in parentheses. Minus letter 1d465. 3 letter 1d465 2 plus 3 letter 1d465 plus 2 letter 1d465 plus 2 minus letter 1d465 3 letter 1d465. Letter 1d465 plus 1 plus 2 letter 1d465 plus 1 minus letter 1d465 3 letter 1d465 plus 2 letter 1d465 plus 1 equals 0, 0, 0. Now we use the zero product property. Notice that we have three factors. Minus letter 1d465 letter 1d465, 3 letter 1d465, plus 2 letter 1d465 letter 1d465, plus 1 letter 1d465 equals 0, 0, 0 minus 230 minus 1. The solutions are 0, minus 23, and minus 1. Try it 5. Solve by factoring. Letter 1d465 3 plus 11 letter 1d465 2 plus 10 letter 1d465 equals 0. Using the square root property. When there is no linear term in the equation, another method of solving a quadratic equation is by using the square root property, in which we isolate the letter 1d465 term and take the square root of the number on the other side of the equals sign. Keep in mind that sometimes we may have to manipulate the equation to isolate the letter 1d465 term so that the square root property can be used. The square root property, with the letter 1d465 term isolated, the square root property states that if letter 1d465 equals letter 1d458, THEN letter 1d465 equals plus letter 1d458 square, where k is a non-zero real number. How to? Given a quadratic equation within letter 1d465 term but no letter 1d465 term, use the square root property to solve it. Isolate the letter 1d465 term on one side of the equal sign. Take the square root of both sides of the equation, putting a plus or minus sign before the expression on the side opposite the squared term. Simplify the numbers on the side with the plus or minus sign. Example 6. Solving a simple quadratic equation using the square root property. Solve the quadratic using the square root property. Letter 1d465 equals 8. Solution. Take the square root of both sides and then simplify the radical. Remember to use a plus or minus sign before the radical symbol. x to letter 1d465 equals 8 plus or minus 8 square plus 22 square. The solutions are 22 square. Example 7. Solving a quadratic equation using the square root property. Solve the quadratic equation. 4 letter 1d4652 plus 1 equals 7. Solution. First, isolate the letter 1d4652 term, then take the square root of both sides. For x2 plus 14x to x to letter 1d465 equals 7,664 plus or minus 6 square root 2. The solutions are 6 square root 2 and minus 6 square root 2. Try it 6. Solve the quadratic equation using the square root property. 3 letter 1d465 minus 42 equals 15. Completing the square. Not all quadratic equations can be factored or can be solved in their original form using the square root property. In these cases, we may use a method for solving a quadratic equation known as completing the square. Using this method, we add or subtract terms to both sides of the equation until we have a perfect square trinomial on one side of the equal sign. We then apply the square root property. To complete the square, the leading coefficient, must equal 1. If it does not, then divide the entire equation by a. Then, we can use the following procedures to solve a quadratic equation by completing the square. We will use the example letter 1d4652 plus 4 letter 1d465 plus 1 equals 0 to illustrate each step. Given a quadratic equation that cannot be factored and with letter 1d44e equals 1, first add or subtract the constant term to the right side of the equal sign. Letter 1d4652 plus 4 letter 1d465 equals minus 1. Multiply the b term by 12 and square it. 12 4, 22 equals 24. Add 12 letter 1d44f 2 to both sides of the equal sign and simplify the right side. We have letter 1d4652 plus 4 letter 1d465 plus 4 letter 1d4652 plus 4 letter 1d465 plus 4 equals minus 1 plus 43. The left side of the equation can now be factored as a perfect square. Letter 1d4652 plus 4 letter 1d465 plus 4. Letter 1d465 plus 2 equals 33. Use the square root property and solve. Letter 1d465 plus 2 square letter 1d465 plus 2 letter 1d465 equals plus 3 square minus 2 plus or minus 3 square. The solutions are minus 2 plus 3 square and minus 2 minus 3 square. Example 8. Solving a quadratic by completing the square. Solve the quadratic equation by completing the square. Letter 1d4652 minus 3, letter 1d465 minus 5 equals 0. Solution. First, move the constant term to the right side of the equal sign. Letter 1d4652 minus 3, letter 1d465 equals 5. Then, take 12 of the b term and square it. 12 minus 3 minus 32 2 equals minus 3,294. Add the result to both sides of the equal sign. Letter 1d4652 minus 3, letter 1d465 plus. Minus 32 2, letter 1d4652 minus 3, letter 1d465 plus 94 equals 5 plus. Minus 3225 plus 94, factor the left side as a perfect square, and simplify the right side. Letter 1d465 minus 32 2 equals 294, use the square root property and solve. Letter 1d465 minus 32 2 square. Letter 1d465 minus 32 letter 1d465 equals plus 294 square plus 29 square root 232 plus or minus 29 square root 2. The solutions are 3 plus 29 square root 2 and 3 minus 29 square root 2. Try it 7. Solve by completing the square. Letter 1d465 2 minus 6, letter 1d465 equals 13. Using the quadratic formula, the fourth method of solving a quadratic equation is by using the quadratic formula, a formula that will solve all quadratic equations. Although the quadratic formula works on any quadratic equation in standard form, it is easy to make errors in substituting the values into the formula. Pay close attention when substituting and use parentheses when inserting a negative number. We can derive the quadratic formula by completing the square. we will assume that the leading coefficient is positive. If it is negative, we can multiply the equation by -1 and obtain a positive a. Given letter 1d44 letter 1d465 2 plus letter 1d44f letter 1d465 plus letter 1d450 equals 0, letter 1d44 not equal to 0. We will complete the square as follows. First, move the constant term to the right side of the equal sign. Letter 1d44 letter 1d465 2 plus letter 1d44f letter 1d465 equals minus letter 1d450. As we want the leading coefficient to equal 1, divide through by a. Letter 1d465 2 plus letter 1d44f letter 1d44 letter 1d465 equals minus letter 1d450 letter 1d44 then. Find 12 of the middle term. And add 12 letter 1d44f letter 1d442 equals letter 1d44f, 24 letter 1d442 to both sides of the equal sign. Letter 1d465 2 plus letter 1d44f letter 1d44 letter 1d465 plus letter 1d44f, 24 letter 1d44 2 equals letter 1d44f, 24 letter 1d44 2 minus letter 1d450 letter 1d44 next. Write the left side as a perfect square. Find the common denominator of the right side and write it as a single fraction. X plus beta letter 1d44 2 equals letter 1d44f, 2 minus 4 letter 1d44 letter 1d450, 4 letter 1d442 now. Use the square root property, which gives x plus b to x plus beta letter 1d44 equals plus letter 1d44f, 2 minus 4 letter 1d44 letter 1d450, 4 letter 1d44 2 square plus letter 1d44f, 2 minus 4 letter 1d44 letter 1d450 square root 2 letter 1d44 finally. Add minus letter 1d44f to a to both sides of the equation and combine the terms on the right side. Thus, letter 1d465 equals minus letter 1d44f plus or minus letter 1d44f. 2 minus 4 letter 1d44 letter 1d450 square 2 letter 1d44 the quadratic formula written in standard form. Letter 1d44 letter 1d465 2 plus letter 1d44f letter 1d465 plus letter 1d450 equals 0. Any quadratic equation can be solved using the quadratic formula. Letter 1d465 equals minus letter 1d44f plus or minus letter 1d44f. 2 minus 4 letter 1d44 letter 1d450 square 2 letter 1d44, where a, b, and c are real numbers and letter 1d44 not equal to 0. How to given a quadratic equation, solve it using the quadratic formula, make sure the equation is in standard form. Letter 1d44 letter 1d465 2 plus letter 1d44f letter 1d465 plus letter 1d450 equals 0. Make note of the values of the coefficients and constant term, ab, and carefully substitute the values noted in step 2 into the equation. To avoid needless errors, use parentheses around each number input into the formula. Calculate and solve. Example 9, solve the quadratic equation using the quadratic formula, solve the quadratic equation. Letter 1d465 2 plus 5 letter 1d465 plus 1 equals 0. Solution, identify the coefficients. Letter 1d44 equals 1 letter 1d44f equals 5, letter 1d450 equals 1. Then use the quadratic formula. Letter 1d465 equals minus 5 plus or minus 5, 2 minus 4, 1. 1 square root 2, 1 minus 5 plus or minus 25 minus 4 square root 2 minus 5 plus or minus 21 square root 2. Example 10, solving a quadratic equation with the quadratic formula. Use the quadratic formula to solve letter 1d465 2 plus letter 1d465 plus 2 equals 0. Solution first, we identify the coefficients. Letter 1d44 equals 1, letter 1d44f equals 1, and letter 1d450 equals 2. Substitute these values into the quadratic formula. Letter 1d465 equals minus letter 1d44f plus or minus letter 1d44f. 2 minus 4 letter 1d44 letter 1d450 square root 2 letter 1d44 minus 1 plus or minus 1, 2 minus 4, 1, 2 square root 2 1 minus 1 plus, or minus 1 minus 8 square root 2 minus 1 plus minus 7 square root 2 minus 1 plus, or minus letter 1 d 4 5 6, 7 square root 2. The solutions to the equation are minus 1 plus letter 1 d 4 5 6, 7 square root 2, and minus 1 minus letter 1 d 4 5 6, 7 square root 2. Try at 8 solve the quadratic equation using the quadratic formula. 9 letter 1 d 4 6 5 2 plus 3 letter 1 d 4 6 5 minus 2 equals 0. The discriminant, the quadratic formula, not only generates the solutions to a quadratic equation, it tells us about the nature of the solutions when we consider the discriminant, or the expression under the radical letter 1 d 4 4 f2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0. The discriminant tells us whether the solutions are real numbers or complex numbers, and how many solutions of each type to expect. Table 1 relates the value of the discriminant to the solutions of a quadratic equation. Value of discriminant results letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 equals 0 1 rational solution. Double solution. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 0. Perfect square 2 rational solutions. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 0. Not a perfect square 2 irrational solutions. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 0. 2 complex solutions. Table 1 the discriminant for letter 1 d 4 4 letter 1 d 4 6 5 2 plus letter 1 d 4 4 f letter 1 d 4 6 5 plus letter 1 d 4 5 0 equals 0. Where a, b, and c are real numbers, the discriminant is the expression under the radical in the quadratic formula. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0. It tells us whether the solutions are real numbers or complex numbers, and how many solutions of each type to expect. Example 11, using the discriminant to find the nature of the solutions to a quadratic equation. Use the discriminant to find the nature of the solutions to the following quadratic equations. A letter 1 d 4 6 5 2 plus 4 letter 1 d 4 6 5 plus 4 equals 0. B 8 letter 1 d 4 6 5 2 plus 14 letter 1 d 4 6 5 plus 3 equals 0. C 3 letter 1 d 4 6 5 2 minus 5 letter 1 d 4 6 5 minus 2 equals 0. D 3 letter 1 d 4 6 5 2 minus 10 letter 1 d 4 6 5 plus 15 equals 0. Solution. Calculate the discriminant. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 for each equation, and state the expected type of solutions. A letter 1 d 4 6 5 2 plus 4 letter 1 d 4 6 5 plus 4 equals 0. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 equals 4. 2 minus 4 1 4 equals 0. There will be one rational double solution. B 8 letter 1 d 4 6 5 2 plus 14 letter 1 d 4 6 5 plus 3 equals 0. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 equals 14. 2 minus 4 8. 3 equals 100. As 100 is a perfect square, there will be two rational solutions. C3 letter 1 d 4 6 5 2 minus 5 letter 1 d 4 6 5 minus 2 equals 0. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 equals minus 5. 2 minus 4 3 minus 2 equals 49. As 49 is a perfect square, there will be two rational solutions. D3 letter 1 d 4 6 5 2 minus 10 letter 1 d 4 6 5 plus 15 equals 0. Letter 1 d 4 4 f 2 minus 4 letter 1 d 4 4 letter 1 d 4 5 0 equals minus 10. 2 minus 4 3. 15 equals minus 80. There will be two complex solutions. Using the Pythagorean theorem, one of the most famous formulas in mathematics is the Pythagorean theorem. It is based on a right triangle and states the relationship among the lengths of the sides as letter 1 d 4 4 e 2 plus letter 1 d 4 4 f 2 equals letter 1 d 4 5 0 2, where A and B refer to the legs of a right triangle adjacent to the 90 degrees angle, and C refers to the hypotenuse. It has immeasurable uses in architecture, engineering, the sciences, geometry, trigonometry, and algebra, and in everyday applications. We use the Pythagorean theorem to solve for the length of one side of a triangle when we have the lengths of the other two. Because each of the terms is squared in the theorem, when we are solving for a side of a triangle, we have a quadratic equation. We can use the methods for solving quadratic equations that we learned in this section to solve for the missing side. The Pythagorean theorem is given as letter 1d44e2 plus letter 1d44f2 equals letter 1d4502, where A and B refer to the legs of a right triangle adjacent to the 90 angle, and C refers to the hypotenuse, as shown in Figure 4. Right triangle with the base labeled, A, the height labeled, B, and the hypotenuse labeled. See Figure 4 Example 12, finding the length of the missing side of a right triangle. Find the length of the missing side of the right triangle in Figure 5. Right triangle with the base labeled, A, the height labeled, 4, and the hypotenuse labeled 12. Figure 5 solution. As we have measurements for side B and the hypotenuse, the missing side is A. A2 plus beta letter 1d44e, 2, plus 4 2 letter 1d44e, 2, plus 16 letter 1d44e to letter 1d44e equals letter 1d450, 2, 12 at 2,140, 4,128,128, square 82, square try. It 9 use the Pythagorean theorem to solve the right triangle problem. Leg A measures 4 units, leg B measures 3 units. Find the length of the hypotenuse. Media access these online resources for additional instruction and practice with quadratic equations. Solving quadratic equations by factoring the zero product property, completing the square quadratic formula, with two rational solutions. Length of a leg of a right triangle 2-5 section. Exercises Verbal 1. How do we recognize when an equation is quadratic? 2. When we solve a quadratic equation, how many solutions should we always start out seeking? Explain why when solving a quadratic equation in the form letter 1d44 letter 1d465, 2 plus letter 1d44f letter 1d465, plus letter 1d450 equals 0. We may graph the equation letter 1d466 equals letter 1d44 letter 1d465, 2 plus letter 1d44f letter 1d465, plus letter 1d450, and have no zeros, x-intercepts. 3. When we solve a quadratic equation by factoring, why do we move all terms to one side, having 0 on the other side? 4. In the quadratic formula, what is the name of the expression under the radical sign letter 1d44f, 2 minus 4 letter 1d44e letter 1d450, and how does it determine the number of and nature of our solutions? 5. Describe two scenarios where using the square root property to solve a quadratic equation would be the most efficient method. Algebraic for the following exercises, solve the quadratic equation by factoring. 6. Letter 1d4652 plus 4 letter 1d465 minus 21 equals 0, 7. Letter 1d4652 minus 9 letter 1d465 plus 18 equals 0, 8. 2 letter 1d4652 plus 9 letter 1d465 minus 5 equals 0, 9. 6 letter 1d4652 plus 17 letter 1d465 plus 5 equals 0, 10. 4 letter 1d465 2 minus 12 letter 1d465 plus 8 equals 0, 11. 3 letter 1d4652 minus 75 equals 0, 12. 8 letter 1d4652 plus 6 letter 1d465 minus 9 equals 0, 13. 4 letter 1d4652 equals 9, 14. 2 letter 1d4652 plus 14 letter 1d465 equals 36, 15. 5 letter 1d4652 equals 5 letter 1d465 plus 30, 16. 4 letter 1d4652 equals 5 letter 1d465, 17. 7 letter 1d4652 plus 3 letter 1d465 equals 0, 18. Letter 1d465 3 minus 9 letter 1d465 equals 2 for the following exercises. Solve the quadratic equation by using the square root property. 19. Letter 1d4652 equals 36, 20. Letter 1d4652 equals 49, 21. Letter 1d465 minus 1, 2 equals 25, 22. Letter 1d465 minus 3, 2 equals 7, 23. 2. Letter 1d465 plus 1 2 equals 924. Letter 1d465 minus 5 2 equals 4 for the following exercises. Solve the quadratic equation by completing the square. Show each step. 25. 26. 2 letter 1d465 2 minus 8 letter 1d465 minus 5 equals 0 27. Letter 1d465 2 minus 6 letter 1d465 equals 1328. Letter 1d465 2 plus 23 letter 1d465 minus 13 equals 0 29. 2 plus letter 1d467 equals 6 letter 1d467 230. 6 letter 1d45d2 plus 7 letter 1d45d minus 20 equals 0 31. 2 letter 1d465 2 minus 3 letter 1d465 minus 1 equals 0 for the following exercises. Determine the discriminant, and then state how many solutions there are and the nature of the solutions. Do not solve. 32. 2 letter 1d465 2 minus 6 letter 1d465 plus 7 equals 0 33. Letter 1d465 2 plus 4 letter 1d465 plus 7 equals 0 34. 3 letter 1d465 2 plus 5 letter 1d465 minus 8 equals 0 35. 9 letter 1d465 2 minus 30 letter 1d465 plus 25 equals 0 36. 2 letter 1d465 2 minus 3 letter 1d465 minus 7 equals 0 37. 6 letter 1d465 2 minus letter 1d465 minus 2 equals 0 for the following exercises. Solve the quadratic equation by using the quadratic formula. If the solutions are not real, state no real solution. 38. 2 letter 1d465 2 plus 5 letter 1d465 plus 3 equals 0 39. Letter 1d465 2 plus letter 1d465 equals 440. 2 letter 1d465 2 minus 8 letter 1d465 minus 5 equals 0 41. 3 letter 1d465 2 minus 5 letter 1d465 plus 1 equals 0 42. Letter 1d465 2 plus 4 letter 1d465 plus 2 equals 0 43. 4 plus 1 letter 1d465 minus 1 letter 1d465 2 equals 0. Technology for the following exercises. Enter the expressions into your graphing utility and find the zeros to the equation, the x-intercepts, by using second CALC2. 0. Recall finding zeros will ask left bound, move your cursor to the left of the 0, enter. Then right bound, move your cursor to the right of the 0, enter. Then guess, move your cursor between the bounds near the 0, enter. Round your answers to the nearest thousandth. 44. Y1 equals 4 letter 1d465 2 plus 3 letter 1d465 minus 2 45. Y1 equals minus 3 letter 1d465 2 plus 8 letter 1d465 minus 146. Y1 equals 0. 5 letter 1d465 2 plus letter 1d465 minus 747. To solve the quadratic equation letter 1d465 2 plus 5 letter 1d465 minus 7 equals 4. We can graph these two equations, y1 equals letter 1d465 2 plus 5 letter 1d465 minus 7y2 equals 4, and find the points of intersection. Recall second CALC5. Intersection. Do this and find the solutions to the nearest tenth. 48. To solve the quadratic equation 0. 3 letter 1d465 2 plus 2 letter 1d465 minus 4 equals 2, we can graph these two equations y1 equals 0. 3 letter 1d465 2 plus 2 letter 1d465 minus 4y2 equals 2, and find the points of intersection. Recall second CALC5. Intersection. Do this and find the solutions to the nearest tenth. Extensions 49. Beginning with the general form of a quadratic equation, letter 1d44 letter 1d465 2 plus letter 1d44f letter 1d465 plus letter 1d450 equals 0. Solve for x by using the completing the square method, thus deriving the quadratic formula. 50. Show that the sum of the two solutions to the quadratic equation is minus letter 1d44f letter 1d44e. 51. A person has a garden that has a length 10 feet longer than the width. Set up a quadratic equation to find the dimensions of the garden if its area is 119 ft. 2. Solve the quadratic equation to find the length and width. 52. Abercrombie and Fitch stock had a price given as letter 1d443 equals 0. 2. Letter 1d461 2 minus 5. 6t plus 50. 2. Where t is the time in months from 1999 to 2001. Letter 1d461 equals 1 is January 1999. Find the 2 months in which the price of the stock was $30, $53. Suppose that an equation is given letter 1d45d equals minus 2 letter 1d465, 2 plus 280 letter 1d465 minus 1000, where x represents the number of items sold at an auction, and p is the profit made by the business that ran the auction. How many items sold would make this profit a maximum? Solve this by graphing the expression in your graphing utility and finding the maximum using second CALC maximum. To obtain a good window for the curve, set x 200 and y 0 10,000. Real-world applications 54. A formula for the normal systolic blood pressure for a man age A, measured in mmHg, is given as letter 1d443 equals 0. 006 letter 1d434 2 minus 0. 2, A plus 120. Find the age to the nearest year of a man whose normal blood pressure measures 125 mmHg. 55. The cost function for a certain company is letter 1d436 equals 60 letter 1d465 plus 300, and the revenue is given by 5x2. Recall that profit is revenue minus cost. Set up a quadratic equation and find two values of x production level that will create a profit of $300, $56. A falling object travels a distance given by the formula letter 1d451 equals 5 letter 1d461 plus 16 letter 1d461 2 ft, where t is measured in seconds. How long will it take for the object to travel 74 ft? 57. A vacant lot is being converted into a community garden. The garden and the walkway around its perimeter have an area of 378 ft2. Find the width of the walkway if the garden is 12 ft, wide by 15 ft, long, a rectangle inside of a larger rectangle. The smaller rectangle has the length labeled 15 feet and the width labeled 12 feet. The distance between the two rectangles is labeled as x on all four sides. 58. An epidemiological study of the spread of a certain influenza strain that hit a small school population found that the total number of students, p, who contracted the flu T days after it broke out, is given by the model letter 1d443 equals minus letter 1d461, 2, plus 13 letter 1d461 plus 130, where 1 less or equal to letter 1d461 less or equal to 6. Find the day that 160 students had the flu. Recall that the restriction on t is at most 6. Learning objectives in this section, you will solve equations involving rational exponents, solve equations using factoring, solve radical equations, solve absolute value equations, solve other types of equations. We have solved linear equations, rational equations, and quadratic equations using several methods. However, there are many other types of equations, and we will investigate a few more types in this section. We will look at equations involving rational exponents, polynomial equations, radical equations, absolute value equations, equations in quadratic form, and some rational equations that can be transformed into quadratics. Solving any equation, however, employs the same basic algebraic rules. We will learn some new techniques as they apply to certain equations, but the algebra never changes. Solving equations involving rational exponents are exponents that are fractions, where the numerator is a power and the denominator is a root. For example, 1612 is another way of writing 16 square. 813 is another way of writing 8 square 3. The ability to work with rational exponents is a useful skill, as it is highly applicable in calculus. We can solve equations in which a variable is raised to a rational exponent by raising both sides of the equation to the reciprocal of the exponent. The reason we raise the equation to the reciprocal of the exponent is because we want to eliminate the exponent on the variable term, and a number multiplied by its reciprocal equals 1. For example, 23, 32 equals 1, 3, 13 equals 1, and so on. Rational exponents: a rational exponent indicates a power in the numerator and a root in the denominator. There are multiple ways of writing an expression, a variable, or a number with a rational exponent. Letter 1d4 4 letter 1d4 5 a letter 1d4 5b equals. Letter 1d4 4 1 letter 1d4 5b letter 1d4 5a equals. Letter 1d4 4 letter 1d4 5a 1 letter 1d4 5b equals. Letter 1d4 4 letter 1d4 5a square letter 1d4 5b equals. Letter 1d4 4 square letter 1d4 5b. Letter 1d4 5a example. 1. Evaluating a number raised to a rational exponent. Evaluate. 823. Solution: whether we take the root first or the power first depends on the number. It is easy to find the cube root of 8, so rewrite 823 as 813, 2. 813, 2 equals 224. Try it 1. Evaluate 64 minus 13. Example 2. Solve the equation including a variable raised to a rational exponent. Solve the equation in which a variable is raised to a rational exponent. Letter 1d46554 equals 32. Solution: the way to remove the exponent on x is by raising both sides of the equation to a power that is the reciprocal of 54, which is 45. Letter 1d46554. Letter 1d46554. 45. Letter 1d465 equals 32. 32, 45. 2. 416. The fifth root of 32 is 2. Try it. 2. Solve the equation. Letter 1d465 32 equals 125. Example 3. Solving an equation involving rational exponents and factoring. Solve 3. Letter 1d465 34 equals letter 1d465 12. Try it. 3. Solve. Letter 1d465 plus 5, 32 equals 8. Solving equations using factoring. We have used factoring to solve quadratic equations, but it is a technique that we can use with many types of polynomial equations, which are equations that contain a string of terms including numerical coefficients and variables. When we are faced with an equation containing polynomials of degree higher than 2, we can often solve them by factoring. Polynomial equations: a polynomial of degree n is an expression of the type letter 1d4 4 letter 1d4 5b letter 1d4 6 5 letter 1d4 5b plus letter 1d4 4 letter 1d4 5b minus 1 letter 1d4 6 5 letter 1d4 5b minus 1 plus letter 1d4 4 to x 2 plus a1x plus a0, where n is a positive integer, and n. a0 are real numbers, and letter 1d4 4 letter 1d4 5b not equal to 0. Setting the polynomial equal to 0 gives a polynomial equation. The total number of solutions, real and complex, to a polynomial equation is equal to the highest exponent n. Example 4. Solving a polynomial by factoring. Solve the polynomial by factoring. 5 letter 1d4654 equals 80 letter 1d4652. Analysis: we can see the solutions on the graph in Figure 1. The x-coordinates of the points where the graph crosses the x-axis are the solutions, the x-intercepts. Notice on the graph that at the solution 0, the graph touches the x-axis and bounces back. It does not cross the x-axis. This is typical of double solutions. Coordinate plane with the x-axis ranging from -5 to 5 and the y-axis ranging from -400 to 500 in intervals of 100. The function 5 times x to the 4th power minus 80x squared equals 0 is graphed along with the points -40, 0, and 40. Figure 1. Try it. 4. Solve by factoring. 12 letter 1d4654 equals 3 letter 1d4652. Example 5. Solve a polynomial by grouping. Solve a polynomial by grouping. Letter 1d465 3 plus letter 1d465 2 minus 9 letter 1d465 minus 9 equals 0. Solution: this polynomial consists of 4 terms, which we can solve by grouping. Grouping procedures require factoring the first 2 terms and then factoring the last 2 terms. If the factors in the parentheses are identical, We can continue the process and solve, unless more factoring is suggested. Letter 1D465 3 plus letter 1D465 2 minus 9, letter 1D465 minus 9, letter 1D465 2. Letter 1D465 plus 1 minus 9, letter 1D465 plus 1. Letter 1D465 2 minus 9. Letter 1D465 plus 1 equals 0, 0, 0. The grouping process ends here, as we can factor letter 1D465 2 minus 9 using the difference of squares formula. Letter 1D465 2 minus 9. Letter 1D465 plus 1. Letter 1D465 minus 3. Letter 1D465 plus 3. Letter 1D465 plus 1. Letter 1D465. Letter 1D465. Letter 1D465 equals 0, 0, 3 minus 3 minus 1. The solutions are 3, minus 3, and minus 1. Note that the highest exponent is 3, and we obtained 3 solutions. We can see the solutions, the x-intercepts, on the graph in Figure 2. Coordinate plane with the x-axis ranging from -5 to 5 and the y-axis ranging from -30 to 20 in intervals of 5. The function x cubed plus x squared minus 9 times x minus 9 equals 0 is graphed along with the points -30, -10, and 30. Figure 2 analysis, we looked at solving quadratic equations by factoring when the leading coefficient is 1. When the leading coefficient is not 1, we solved by grouping. Grouping requires 4 terms, which we obtained by splitting the linear term of quadratic equations. We can also use grouping for some polynomials of degree higher than 2, as we saw here, since there were already 4 terms. Solving radical equations are equations that contain variables in the radicand, the expression under a radical symbol, such as 3 letter 1D465 plus 18 square letter 1D465 plus 3 square letter 1D465 plus 5 square minus letter 1D465 minus 3 square equals letter 1D465 letter 1D465 minus 32. Radical equations may have one or more radical terms and are solved by eliminating each radical, one at a time. We have to be careful when solving radical equations, as it is not unusual to find extraneous solutions, roots that are not, in fact, solutions to the equation. These solutions are not due to a mistake in the solving method, but result from the process of raising both sides of an equation to a power. However, checking each answer in the original equation will confirm the true solutions. Radical equations, an equation containing terms with a variable in the radicand, is called a radical equation. How to given a radical equation, solve it. Isolate the radical expression on one side of the equal sign. Put all remaining terms on the other side. If the radical is a square root, then square both sides of the equation. If it is a cube root, then raise both sides of the equation to the third power. In other words, for an nth root radical, raise both sides to the nth power. Doing so eliminates the radical symbol. Solve the remaining equation. If a radical term still remains, repeat steps 1, 2. Confirm solutions by substituting them into the original equation. Example 6, solving an equation with one radical. Solve 15 minus 2, letter 1D465 square equals letter 1D465. Solution, the radical is already isolated on the left side of the equal side, so proceed to square both sides. 15 minus 2, letter 1D465 square. 15 minus 2, letter 1D465 square 200. 15 minus 2, letter 1D465 equals letter 1D465. Letter 1D465 2, letter 1D465 2. We see that the remaining equation is a quadratic. Set it equal to 0 and solve. Plus 2, letter 1D465 minus 15, letter 1D465 plus 5. Letter 1D465 minus 3, minus 53. The proposed solutions are minus 5 and 3. Let us check each solution back in the original equation. First, check letter 1D465 equals minus 5. 15 minus 2, letter 1D465 square. 15 minus 2 minus 5, square 25 square 5 equals not, letter 1D465 minus 5 minus 5 minus 5. This is an extraneous solution. While no mistake was made solving the equation, we found a solution that does not satisfy the original equation. Check letter 1D465 equals 3. 15 minus 2, letter 1 d465 square, 15 minus 2, 3. Square 9 square 3 equals letter 1 d465 333, the solution is 3. Try it 5, solve the radical equation. Letter 1 d465 plus 3 square equals 3 letter 1 d465 minus 1 example, 7. Solving a radical equation containing two radicals, solve 2 letter 1 d465 plus 3 square plus letter 1 d465 minus 2 square equals 4. Solution: as this equation contains two radicals, we isolate one radical, eliminate it, and then isolate the second radical. 2 letter 1 d465 plus 3 square plus letter 1 d465 minus 2 square 2 letter 1 d465 plus 3 square 2 letter 1 d465 plus 3 squared 2 equals 44 minus letter 1 d465 minus 2 square. 4 minus letter 1 d465 minus 2 squared 2, subtract letter 1 d465 minus 2 square from both sides. Square both sides. Use the perfect square formula to expand the right side. Letter 1 d44e minus letter 1 d44f2 equals letter 1 d44e, 2 minus 2 letter 1 d44e letter 1 d44f plus letter 1 d44f2. 2 letter 1 d465 plus 32 letter 1 d465 plus 32 letter 1 d465 plus 3 letter 1 d465 minus 11. Letter 1 d465 minus 11 2 letter 1 d465 2 minus 22 letter 1 d465 plus 121 equals 4 2 minus 2 4 letter 1 d465 minus 2 square plus letter 1 d465 minus 2 square 216 minus 8 letter y. Like terms, isolate the second radical. Square both sides. Now that both radicals have been eliminated, set the quadratic equal to 0 and solve. Letter 1 d465 2 minus 22 letter 1 d465 plus 121 letter 1 d465 2 minus 86 letter 1 d465 plus 249. Letter 1 d465 minus 3. Letter 1 d465 minus 83. Letter 1 d465 letter 1 d465 equals 64 letter 1 d465 minus 12,800,383 factor and solve. The proposed solutions are 3 and 83. Check each solution in the original equation. 2 letter 1 d465 plus 3 square plus letter 1 d465 minus 2 square 2 letter 1 d465 plus 3 square 2, 3. Plus 3 square 9 square 3 equals 44 minus letter 1 d465 minus 2 square 4 minus 3 minus 2 square 4 minus 1 square 3, 1 solution is 3. Check letter 1 d465 equals 83. 2 letter 1 d465 plus 3 square plus letter 1 d465 minus 2 square 2 letter 1 d465 plus 3 square 2, 83. Plus 3 square 169 square 13 equals not 44 minus letter 1 d465 minus 2 square 4 minus 83 minus 2 square 4 minus 80 1 square minus 5. The only solution is 3. We see that 83 is an extraneous solution. Try it 6, solve the equation with two radicals. 3 letter 1 d465 plus 7 square plus letter 1 d465 plus 2 square equals 1. Solving an absolute value equation next, we will learn how to solve an absolute value equation. To solve an equation such as 2 letter 1 d465 minus 6 equals 8, we notice that the absolute value will be equal to 8 if the quantity inside the absolute value bars is 8 or minus 8. This leads to two different equations we can solve independently. 2 letter 1 d465 minus 62 letter 1 d465 letter 1 d465 equals 8,147, or to letter 1 d465 minus 62 letter 1 d465 letter 1 d465 equals minus 8 minus 2 minus 1. Knowing how to solve problems involving absolute value functions is useful. For example, we may need to identify numbers or points on a line that are at a specified distance from a given reference point. Absolute value equations: the absolute value of x is written as letter 1 d465. It has the following properties. If letter 1 d465 greater or equal to 0, then letter 1 d465 equals letter 1 d465. If letter 1 d465 0, then letter 1 d465 equals minus letter 1 d465. For real numbers a and b, An equation of the form letter 1 d434 equals letter 1 d435, with letter 1 d435 greater or equal to 0, we'll have solutions when letter 1 d434 equals letter 1 d435 or letter 1 d434 equals minus letter 1 d435. If letter 1 d435 0, the equation has no solution. An absolute value equation in the form letter 1 d44 letter 1 d465 plus letter 1 d44f equals letter 1 d450 has the following properties. If letter 1 d450 0, letter 1 d44 letter 1 d465 plus letter 1 d44f equals letter 1 d450 has no solution. If letter 1 d450 equals 0, letter 1 d44 letter 1 d465 plus letter 1 d44f equals letter 1 d450 has one solution. If letter 1 d450 0, letter 1 d44 letter 1 d465 plus letter 1 d44f equals letter 1 d450 has two solutions. How to given an absolute value equation, solve it. Isolate the absolute value expression on one side of the equal sign. If letter 1 d450 0, write and solve two equations. Letter 1 d44 letter 1 d465 plus letter 1 d44f equals letter 1 d450 and letter 1 d44 letter 1 d465 plus letter 1 d44f equals minus letter 1 d450. Example 8, solving absolute value equations. Solve the following absolute value equations. A6 letter 1 d465 plus 4 equals 8b3 letter 1 d465 plus 4 equals minus 9c. D minus 5 letter 1 d465 plus 10 equals 0 solution, A6 letter 1 d465 plus 4 equals 8. Write two equations and solve each. 6 letter 1 d465 plus 46 letter 1 d465 letter 1 d465 equals 84,236 letter 1 d465 plus 46 letter 1 d465 letter 1 d465 equals minus 8 minus 12 minus 2. The two solutions are 23 and minus 2. B3 letter 1 d465 plus 4 equals minus 9. There is no solution as an absolute value cannot be negative. C. Isolate the absolute value expression and then write two equations. 3 letter 1 d465 minus 53 letter 1 d465 letter 1 d465 equals 10,155 3 letter 1 d465 minus 5 minus 4 3 letter 1 d465 minus 5 equals 6,103 letter 1 d465 minus 53 letter 1 d465 letter 1 d465 equals minus 10 minus 5 minus 53. There are two solutions. 5 and minus 53. D minus 5 letter 1 d465 plus 10 equals 0. The equation is set equal to 0, so we have to write only one equation. Minus 5 letter 1 d465 plus 10 minus 5 letter 1 d465 letter 1 d465 equals 0 minus 102. There is one solution. 2. Try it 7. Solve the absolute value equation. 1 minus 4 letter 1 d465 plus 8 equals 13. Solving other types of equations, there are many other types of equations in addition to the ones we have discussed so far. We will see more of them throughout the text. Here, we will discuss equations that are in quadratic form and rational equations that result in a quadratic. Solving equations in quadratic form. Equations in quadratic form are equations with three terms. The first term has a power other than 2. The middle term has an exponent that is 1/2 the exponent of the leading term. The third term is a constant. We can solve equations in this form as if they were quadratic. A few examples of these equations include letter 1 d465 4 minus 5 letter 1 d465 2 plus 4 equals 0. Letter 1 d465 6 plus 7 letter 1 d465 3 minus 8 equals 0. And letter 1 d465 23 plus 4 letter 1 d465 13 plus 2 equals 0. In each one, doubling the exponent of the middle term equals the exponent on the leading term. We can solve these equations by substituting a variable for the middle term. Quadratic form, if the exponent on the middle term is 1/2 of the exponent on the leading term, we have an equation in quadratic form, which we can solve as if it were a quadratic. We substitute a variable for the middle term to solve equations in quadratic form. How to given an equation quadratic in form, solve it. Identify the exponent on the leading term and determine whether it is double the exponent on the middle term. If it is, substitute a variable, such as u, for the variable portion of the middle term. Rewrite the equation so that it takes on the standard form of a quadratic. Solve using one of the usual methods for solving a quadratic. Replace the substitution variable with the original term. Solve the remaining equation. Example 9, solving a fourth-degree equation in quadratic form. Solve this fourth-degree equation. 3 letter 1d465 4 minus 2 letter 1d465 2 minus 1 equals 0. Solution: this equation fits the main criteria, that the power on the leading term is double the power on the middle term. Next, we will make a substitution for the variable term in the middle. Let letter 1d462 equals letter 1d4652. Rewrite the equation in u. 3 letter 1d4622 minus 2 letter 1d462 minus 1 equals 0. Now solve the quadratic. 3 letter 1d4622 minus 2 letter 1d462 minus 1, 3 letter 1d462 plus 1, letter 1d462 minus 1 equals 0, 0. Solve each factor and replace the original term for u. 3 letter 1d462 plus 13 letter 1d462 letter 1d462 letter 1d465 to letter 1d465 equals 0 minus 1 minus 13 plus, or minus letter 1d456. 13 square letter 1d462 minus 1 letter 1d462 letter 1d465 to letter 1d465 equals 0, 11 plus or minus 1. The solutions are plus or minus letter 1d456 13 square and plus or minus 1. Try it 8. Solve using substitution. Letter 1d465 4 minus 8, letter 1d465 2 minus 9 equals 0. Example 10, solving an equation in quadratic form containing a binomial. Solve the equation in quadratic form. Letter 1d465 plus 2, 2 plus 11, letter 1d465 plus 2 minus 12 equals 0. Solution: this equation contains a binomial in place of the single variable. The tendency is to expand what is presented. However, recognizing that it fits the criteria for being in quadratic form makes all the difference in the solving process. First, make a substitution, letting letter 1d462 equals letter 1d465 plus 2. Then rewrite the equation in u. Letter 1d462 2 plus 11 letter 1d462 minus 12, letter 1d462 plus 12. Letter 1d462 minus 1 equals 0, 0. Solve using the zero factor property, and then replace u with the original expression. Letter 1d462 plus 12 letter 1d462 letter 1d465 plus 2 letter 1d465 equals 0 minus 12 minus 14. The second factor results in letter 1d462 minus 1 letter 1d462 letter 1d465 plus 2 letter 1d465 equals 0, 11 minus 1. We have two solutions, minus 14 and minus 1. Try it 9. Solve. Letter 1d465 minus 5 2 minus 4, letter 1d465 minus 5 minus 21 equals 0. Solving rational equations resulting in a quadratic. Earlier, we solved rational equations. Sometimes, solving a rational equation results in a quadratic. When this happens, we continue the solution by simplifying the quadratic equation by one of the methods we have seen. It may turn out that there is no solution. Example 11, solving a rational equation leading to a quadratic. Solve the following rational equation. Minus 4 letter 1d465 letter 1d465 minus 1 plus 4 letter 1d465 plus 1 equals minus 8 letter 1d465 2 minus 1. Solution: we want all denominators in factored form to find the LCD. Two of the denominators cannot be factored further. However, letter 1d465 2 minus 1 equals letter 1d465 plus 1, letter 1d465 minus 1. Then the LCD is letter 1d465 plus 1, letter 1d465 minus 1. Next, we multiply the whole equation by the LCD. Letter 1d465 plus 1, letter 1d465 minus 1, minus 4 letter 1d465 letter 1d465 minus 1, plus 4 letter 1d465, plus 1 minus 4 letter 1d465. Letter 1d465 plus 1, plus 4 letter 1d465 minus 1, minus 4 letter 1 d465 2 minus 4 letter 1 d465 plus 4 letter 1 d465 minus 4 letter 1 d465 2. In this case, either solution produces a 0 in the denominator in the original equation. Thus, there is no solution. Try it 10 solve 3 letter 1 d465 plus 2 letter 1 d465 minus 2 plus 1 letter 1 d465 equals minus 2 letter 1 d465 2 minus 2 letter 1 d465. Media access, these online resources for additional instruction and practice with different types of equations. Rational equation with no solution, solving equations with rational exponents using reciprocal powers, solving radical equations, Part 1 of 2, solving radical equations, Part 2 of 2. 6-section exercises verbal 1. In a radical equation, what does it mean if a number is an extraneous solution? 2. Explain why possible solutions must be checked in radical equations. 3. Your friend tries to calculate the value minus 932 and keeps getting an error message. What mistake are they probably making? 4. Explain why 2 letter 1 d465 plus 5 equals minus 7 has no solutions. 5. Explain how to change a rational exponent into the correct radical expression. Algebraic for the following exercises, solve the rational exponent equation. Use factoring where necessary. 6. Letter 1 d465 23 equals 16.7. Letter 1 d465 34 equals 27.8. 2. Letter 1 d465 12 minus letter 1 d465 14 equals 0.9. Letter 1 d465 minus 1 34 equals 8.10. Letter 1 d465 plus 1 23 equals 4.11. Letter 1 d465 23 minus 5 letter 1 d465 13 plus 6 equals 0.12. Letter 1 d465 73 minus 3 letter 1 d465 43 minus 4 letter 1 d465 13 equals 0 for the following exercises. Solve the following polynomial equations by grouping and factoring. 13. Letter 1 d465 3 plus 2 letter 1 d465 2 minus letter 1 d465 minus 2 equals 0.14. 3 letter 1 d465 3 minus 6 letter 1 d465 2 minus 27 letter 1 d465 plus 54 equals 0.15. 4 letter 1 d466 3 minus 9 letter 1 d466 equals 0.16. Letter 1 d465 3 plus 3 letter 1 d465 2 minus 25 letter 1 d465 minus 75 equals 0.17. Letter 1 d45a 3 plus letter 1 d45a 2 minus letter 1 d45a minus 1 equals 0. 18 2 letter 1 d465 5 minus 14 letter 1 d465 3 equals 0.19. 5 letter 1 d465 3 plus 45 letter 1 d465 equals 2 letter 1 d465 2 plus 18 for the following exercises. Solve the radical equation. Be sure to check all solutions to eliminate extraneous solutions. 23 letter 1 d465 minus 1 square minus 2 equals 0.21. Letter 1 d465 minus 7 square equals 5.22. Letter 1 d465 minus 1 square equals letter 1 d465 minus 7.23. 3 letter 1 d461 plus 5 square equals 7.24. Letter 1 d461 plus 1 square plus 9 equals 7.25. 12 minus letter 1 d465 square equals letter 1 d465 26. 2 letter 1 d465 plus 3 square minus letter 1 d465 plus 2 square equals 227. 3 letter 1 d465 plus 7 square plus letter 1 d465 plus 2 square equals 128. 2 letter 1 d465 plus 3 square minus letter 1 d465 plus 1 square equals 1 for the following exercises. Solve the equation involving absolute value. 29. 3 letter 1 d465 minus 4 equals 830. 2 letter 1 d465 minus 3 equals minus 231. 1 minus 4 letter 1 d465 minus 1 equals 532. 4 letter 1 d465 plus 1 minus 3 equals 633. 2 letter 1 d465 minus 1 minus 7 equals minus 234. 2 letter 1d465 plus 1 minus 2 equals minus 335. Letter 1d465 plus 5 equals 036. For the following exercises, solve the equation by identifying the quadratic form. Use a substitute variable and find all real solutions by factoring. 37. Letter 1d465 4 minus 10, letter 1d465 2 plus 9 equals 038. 4. Letter 1d461 minus 1 2 minus 9. Letter 1d461 minus 1 equals minus 239. Letter 1d465 2 minus 1 2 plus, letter 1d465 2 minus 1 minus 12 equals 040. Letter 1d465 plus 1 2 minus 8. Letter 1d465 plus 1 minus 9 equals 041. Extensions for the following exercises. Solve for the unknown variable. 42. Letter 1d465 minus 2 minus letter 1d465 minus 1 minus 12 equals 043. Letter 1d465 2 square equals letter 1d465 44. Letter 1d461 10 minus 2, letter 1d461 5, plus 1 equals 045. Letter 1d465 2 plus 2 letter 1d465 minus 36 equals 12 real-world applications for the following exercises. Use the model for the period of a pendulum, t, such that letter 1d447 equals 2 letter 1d70b, letter 1d43f letter 1d454 square, where the length of the pendulum is L and the acceleration due to gravity is g. 46. If the acceleration due to gravity is 9.8 ms2 and the period equals 1s, find the length to the nearest cm, 100 cm equals 1 m. 47. If the gravity is 32 ft/s2 and the period equals 1s, find the length to the nearest in. 12 in equals 1 ft. Round your answer to the nearest in. For the following exercises, use a model for body surface area, BSA, such that letter 1d435 letter 1d446 letter 1d434 equals letter 1d464 letter 210e 3600 square, where W equals weight in kg and H equals height in cm. 48. Find the height of a 72 kg female to the nearest cm whose letter 1d435 letter 1d446 letter 1d434 equals 1. 849. Find the weight of a 177 cm male to the nearest kg whose letter 1d435 letter 1d446 letter 1d434 equals 2. 1. Learning objectives in this section, you will use interval notation, use properties of inequalities, solve inequalities in one variable algebraically, solve absolute value inequalities. Several red winners' ribbons lie on a white table. Figure 1, it is not easy to make the honor roll at most top universities. Suppose students were required to carry a course load of at least 12 credit hours and maintain a grade point average of 3.5 or above. How could these honor roll requirements be expressed mathematically? In this section, we will explore various ways to express different sets of numbers, inequalities, and absolute value inequalities. Using interval notation, indicating the solution to an inequality, such as letter 1d465 greater or equal to 4, can be achieved in several ways. We can use a number line as shown in Figure 2. The blue ray begins at letter 1d465 equals 4, and, as indicated by the arrowhead, continues to infinity, which illustrates that the solution set includes all real numbers greater than or equal to 4. A number line starting at 0, with the last tick mark being labeled 11. There is a dot at the number 4 and an arrow extends toward the right. Figure 2, we can use set builder notation. Letter 1d465, letter 1d465 greater or equal to 4, which translates to all real numbers x such that x is greater than or equal to 4. Notice that braces are used to indicate a set. The third method is interval notation, in which solution sets are indicated with parentheses or brackets. The solutions to letter 1d465 greater or equal to 4 are represented as 4 infinity. This is perhaps the most useful method, as it applies to concepts studied later in this course and to other higher-level math courses. The main concept to remember is that parentheses represent solutions greater or less than the number, and brackets represent solutions that are greater than or equal to or less than or equal to the number. Use parentheses to represent infinity or negative infinity, since positive and negative infinity are not numbers in the usual sense of the word, and therefore cannot be equaled. A few examples of an interval, or a set of numbers in which a solution falls, are -2, 6, or all numbers between -2 and 6, including -2 but not including 6. -1, 0, all real numbers between but not including -1 and 0, and -infinity, 1, all real numbers less than and including 1. Table 1 outlines the possibilities. Set indicated set builder notation, interval notation, all real numbers between a and b, but not including a or b, letter 1 D465, letter 1 D44E, letter 1 D465, letter 1 D44F. A, b, all real numbers greater than a, but not including a letter 1 D465, letter 1 D465, letter 1 D44E. A, infinity, all real numbers less than b, but not including b, letter 1 D465, letter 1 D465, letter 1 D44F. -infinity, b, all real numbers greater than a, including a letter 1 D465, letter 1 D465 greater, or equal to letter 1 D44E, letter 1 D44E. Infinity, all real numbers less than b, including b, letter 1 D465, letter 1 D465, less or equal to letter 1 D44F. -infinity, letter 1 D44F, all real numbers between a and b, including a letter 1 D465, letter 1 D44E, less or equal to letter 1 D465, letter 1 D44F, letter 1 D44E. B, all real numbers between a and b, including b, letter 1 D465, letter 1 D44E, letter 1 D465, less or equal to letter 1 D44F. A, letter 1 D44F, all real numbers between a and b, including a and b, letter 1 D465, letter 1 D44E, less or equal to letter 1 D465, less or equal to letter 1 D44F, letter 1 D44E. Letter 1 D44F, all real numbers less than a or greater than b, letter 1 D465, letter 1 D465, letter 1 D44E, or letter 1 D465, letter 1 D44F. -infinity, letter 1 D44E, letter 1 D44F, infinity, all real numbers, letter 1 D465, letter 1 D465, is all real numbers. -infinity. Infinity, table 1 example 1 using interval notation to express all real numbers greater than or equal to a use interval notation to indicate all real numbers greater than or equal to -2. Solution, use a bracket on the left of -2 and parentheses after infinity. -2 infinity. The bracket indicates that -2 is included in the set with all real numbers greater than -2 to infinity. Try at 1 use interval notation to indicate all real numbers between and including -3 and 5 example 2 using interval notation to express all real numbers less than or equal to a or greater than or equal to be write the interval expressing all real numbers less than or equal to -1 or greater than or equal to 1. Solution, we have to write 2 intervals for this example. The first interval must indicate all real numbers less than or equal to 1. So, this interval begins at -infinity and ends at -1, which is written as -infinity, -1. The second interval must show all real numbers greater than or equal to 1, which is written as 1, infinity. However, we want to combine these two sets. We accomplish this by inserting the union symbol between the two intervals. -infinity, -1, 1. Infinity, try it to express all real numbers less than -2 or greater than or equal to 3 in interval notation. Using the properties of inequalities when we work with inequalities, we can usually treat them similarly to, but not exactly as we treat equalities. We can use the addition property and the multiplication property to help us solve them. The one exception is when we multiply or divide by a negative number. Doing so reverses the inequality symbol. Properties of inequalities. Letter 1 D4 0 0, letter 1 D4 1 D, letter 1 D4 1 D, letter 1 D4 2 2, letter 1 D4 2 D, letter 1 D4 2 2. Letter 1 D4 0 F, letter 1 D4 2 B, letter 1 D4 2 8, letter 1 D4 2 9, letter 1 D4 1 A, letter 1 D4 2 B, letter 1 D4 2 D. Letter 1D40 C, letter 1D42, letter 1D425, letter 1D42D, letter 1D422, letter 1D429, letter 1D422, letter 1D40 F letter. THEN letter 1D44E, plus letter 1D450, letter 1D44F, plus letter 1D450. IF letter 1D44E, letter 1D44F, AND letter 1D450, 0THEN letter 1D44E, letter 1D450, letter 1D44F, letter 1D450. IF letter 1D44E, letter 1D44F, AND letter 1D450, 0THEN letter 1D44E, letter 1D450, letter 1D44F, letter 1D450. These properties also apply to letter 1D44E, less or equal to letter 1D44F, letter 1D44E, letter 1D44F, and letter 1D44E greater or equal to letter 1D44F. Example 3, demonstrating the addition property. Illustrate the addition property for inequalities by solving each of the following. A, letter 1D465 minus 154B6 greater or equal to letter 1D465 minus 1C. Solution: the addition property for inequalities states that if an inequality exists, adding or subtracting the same number on both sides does not change the inequality. A, letter 1D465 minus 154 letter 1D465 minus 15 plus 154 plus 15 letter 1D465 19. Add 15 to both sides. B, 6 greater or equal to letter 1D465 minus 16 plus 1 greater or equal to letter 1D465 minus 1 plus 17 greater or equal to letter 1D465. Add 1 to both sides. C, letter 1D465 plus 7 9 letter 1D465 plus 7 minus 7 9 minus 7 letter 1D465 2. Subtract 7 from both sides. Try it 3 solve. 3 letter 1D465 minus 2 1. Example 4, demonstrating the multiplication property. Illustrate the multiplication property for inequalities by solving each of the following. A, 3 letter 1D465 6B minus 2 letter 1D465 minus 1 greater or equal to 5C5 minus letter 1D465 10. Solution: 3 letter 1D465 613, 3 letter 1D465 6, 13 letter 1D465 2B. Minus 2 letter 1D465 minus 1 greater or equal to 5 minus 2 letter 1D465 greater or equal to 6, minus 12. Minus 2 letter 1D465 greater or equal to 6, minus 12 letter 1D465 less minus 3 multiply by minus 12. Reverse the inequality. C, 5 minus letter 1D465 10 minus letter 1D465 5 minus 1 minus letter 1D465 5 minus 1 letter 1D465 minus 5 multiply by minus 1. Reverse the inequality. Try it 4 solve. 4 letter 1D465 plus 7 greater or equal to 2 letter 1D465 minus 3. Solving inequalities in one variable algebraically, as the examples have shown, we can perform the same operations on both sides of an inequality, just as we do with equations. We combine like terms and perform operations. To solve, we isolate the variable. Example 5, solving an inequality algebraically. Solve the inequality. 13 minus 7 letter 1D465 greater or equal to 10 letter 1D465 minus 4. Solution: solving this inequality is similar to solving an equation up until the last step. 13 minus 7 letter 1D465 greater or equal to 10 letter 1D465 minus 400. 13 minus 17 letter 1D465 greater minus 4 minus 17 letter 1D465 greater minus 17 letter 1D465 less or equal to 1. Move variable terms to one side of the inequality. Isolate the variable term. Dividing both sides by minus 17 reverses the inequality. The solution set is given by the interval minus infinity, 1, or all real numbers less than and including 1. Try it 5 solve the inequality and write the answer using interval notation. Minus letter 1D465 plus 412 letter 1D465 plus 1. Example 6, solving an inequality with fractions. Solve the following inequality and write the answer in interval notation. Minus 34 letter 1D465 greater minus 58 plus 23 letter 1d465. Solution: we begin solving in the same way we do when solving an equation. Minus 34 letter 1d465 greater minus 58 plus 23 letter 1d465 minus 34 letter 1d465 minus 23 letter 1d465 greater minus 58 minus 912. Letter 1d465 minus 812. Letter 1d465 greater minus 58 minus 1712. Letter 1d465 greater minus 58. Letter 1d465 less minus 58. Variable terms on one side. Write fractions with common denominator. Multiplying by a negative number reverses the inequality. The solution set is the interval, minus infinity, 1534. Try at 6 solve the inequality and write the answer in interval notation. Minus 56 letter 1d465 less or equal to 34 plus 83 letter 1d465. Understanding compound inequalities, a compound inequality includes two inequalities in one statement. A statement such as 4 letter 1d465 less or equal to 6 means 4 letter 1d465 and letter 1d465 less or equal to 6. There are two ways to solve compound inequalities: separating them into two separate inequalities, or leaving the compound inequality intact and performing operations on all three parts at the same time. We will illustrate both methods. Example 7, solving a compound inequality. Solve the compound inequality. 3 less or equal to 2 letter 1d465 plus 2 6. Solution: the first method is to write two separate inequalities. 3 less or equal to 2 letter 1d465 plus 2 and 2 letter 1d465 plus 2 6. We solve them independently. 3 less or equal to 2 letter 1d465 plus 21 less or equal to 2 letter 1d465 12 less or equal to letter 1d465 at n deta letter 1d465 plus 262 letter 1d465 4 letter 1d465 2. Then we can rewrite the solution as a compound inequality, the same way the problem began. 12 less or equal to letter 1d465 2 in interval notation. The solution is written as 12 2. The second method is to leave the compound inequality intact and perform solving procedures on the three parts at the same time. 3 less or equal to 2 letter 1d465 plus 261 less or equal to 2 letter 1d465 412 less or equal to letter 1d465 2. Isolate the variable term and subtract 2 from all three parts. Divide through all three parts by 2. We get the same solution, 12 2. Try at 7, solve the compound inequality. 4 2 letter 1d465 minus 8 less or equal to 10. Example 8, solving a compound inequality with the variable in all three parts. Solve the compound inequality with variables in all three parts. 3 plus letter 1d465, 7 letter 1d465, minus 2, 5 letter 1d465 minus 10. Solution: let's try the first method. Write two inequalities. 3 plus letter 1d465, 7 letter 1d465 minus 23 6, letter 1d465 minus 25 6, letter 1d465 56, letter 1d465 letter 1d465 56, and 7 letter 1d465 minus 2 5 letter 1d465 minus 102 letter 1d465 minus 2 minus 102 letter 1d465 minus 8 letter 1d465 minus 4 minus 5. The solution set is minus 4 letter 1d465 56, or in interval notation, minus 4 56. Notice that when we write the solution in interval notation, the smaller number comes first. We read intervals from left to right as they appear on a number line. See Figure 3. A number line with the points and 5 6 labeled. Dots appear at these points and a line connects these two dots. Figure 3. Try at 8, solve the compound inequality. 3 letter 1d466, 4 minus 5 letter 1d4665, plus 3 letter 1d466. Solving absolute value inequalities, as we know, the absolute value of a quantity is a positive number, or 0. From the origin, a point located at minus letter 1d465, 0, has an absolute value of x, as it is x units away. Consider absolute value as the distance from one point to another point. Regardless of direction, positive or negative, the distance between the 2 points is represented as a positive number or 0. An absolute value inequality is an equation of the form letter 1 d434 letter 1 d435, letter 1 d434 less letter 1 d435, letter 1 d434 letter 1 d435, or letter 1 d434 greater letter 1 d435, where A, and sometimes B, represents an algebraic expression dependent on a variable x. Solving the inequality means finding the set of all x values that satisfy the problem. Usually this set will be an interval or the union of two intervals and will include a range of values. There are two basic approaches to solving absolute value inequalities: graphical and algebraic. The advantage of the graphical approach is we can read the solution by interpreting the graphs of two equations. The advantage of the algebraic approach is that solutions are exact, as precise solutions are sometimes difficult to read from a graph. Suppose we want to know all possible returns on an investment if we could earn some amount of money within $200 of $600. We can solve algebraically for the set of x values such that the distance between x and 600 is less than or equal to 200. We represent the distance between x and 600 as letter 1d465 minus 600, and therefore, letter 1d465 minus 600 less 200, or minus 200, less or equal to letter 1d465 minus 600, less or equal to 200 minus 200 plus 600, less or equal to letter 1d465 minus 600 plus 600, less or equal to 200 plus 600,400, less or equal to letter 1d465, less or equal to 800. This means our returns would be between $400 and $800. To solve absolute value inequalities, just as with absolute value equations, we write two inequalities and then solve them independently. Absolute value inequalities for an algebraic expression x and letter 1d4580. An absolute value inequality is an inequality of the form letter 1d44b letter 1d458. Is equivalent to minus letter 1d458 letter 1d44b letter 1d458 letter 1d44b letter 1d458. Is equivalent to letter 1d44b minus letter 1d458. Or letter 1d44b, letter 1d458. These statements also apply to letter 1d44b less letter 1d458 and letter 1d44b greater letter 1d458. Example 9. Determining a number within a prescribed distance. Describe all values x within a distance of 4 from the number 5. Solution: we want the distance between x and 5 to be less than or equal to 4. We can draw a number line, such as in Figure 4, to represent the condition to be satisfied. A number line with one tick mark in the center labeled 5. The tick marks on either side of the center 1 are not marked. Arrows extend from the center tick mark to the outer tick marks. Both are labeled 4. Figure 4. The distance from x to 5 can be represented using an absolute value symbol, letter 1d465 minus 5. Write the values of x that satisfy the condition as an absolute value inequality. Letter 1d465 minus 5 less 4, we need to write two inequalities as there are always two solutions to an absolute value equation. Letter 1d465 minus 5 less or equal to 4 letter 1d465 less or equal to 9 and letter 1d465 minus 5 greater minus 4 letter 1d465 greater or equal to 1 if the solution set is letter 1d465 less or equal to 9 and letter 1d465 greater or equal to 1. Then the solution set is an interval including all real numbers between and including 1 and 9. So letter 1d465 minus 5 less 4 is equivalent to 1, 9, in interval notation. Try at 9. Describe all x values within a distance of 3 from the number 2. Example 10. Solving an absolute value inequality. Solve letter 1d465 minus 1 less 3. Solution: letter 1d465 minus 1 less 3 minus 3 less or equal to letter 1d465 minus 1 less or equal to 3 minus 2 less or equal to letter 1d465 less or equal to 4 minus 2. 4. Example 11. Using a graphical approach to solve absolute value inequalities. Given the equation letter 1d466 equals minus 12 4 letter 1d465 minus 5 plus 3. Determine the x values, for which the y values are negative. Solution: we are trying to determine where letter 1d4660, which is when minus 12 4 letter 1d465 minus 5 plus 3 0. We begin by isolating the absolute value. Minus 12 4 letter 1d465 minus 5 minus 3 4 letter 1d465 minus 5 6. Multiply both sides by 2 and reverse the inequality. Next, we solve for the equality 4 letter 1d465 minus 5 equals 6. 4 letter 1d465 minus 5 equals 64 letter 1d465 equals 11 letter 1d465 equals 114, or 4 letter 1d465 minus 5 equals minus 64 letter 1d465 equals minus 1 letter 1d465 equals minus 14 now. We can examine the graph to observe where the y values are negative. We observe where the branches are below the x-axis. Notice that it is not important exactly what the graph looks like, as long as we know that it crosses the horizontal axis at letter 1d465 equals minus 14 and letter 1d465 equals 114, and that the graph opens downward. See Figure 5. A coordinate plan with the x-axis ranging from minus 5 to 5 and the y-axis ranging from minus 4 to 4. The function y equals minus 1/24x, 5 plus 3 is graphed. An open circle appears at the point minus 0, 25, and an arrow Figure 5 try, it 10 solve minus 2, letter 1d458 minus 4 less minus 6. Media access: these online resources for additional instruction and practice with linear inequalities and absolute value inequalities. Interval notation: how to solve linear inequalities, how to solve an inequality absolute value equations, compound inequalities absolute value inequalities 2. 7 section exercises verbal 1. When solving an inequality, explain what happened from step 1 to step 2. Step 1 step 2 minus 2 letter 1d465 6 letter 1d465 minus 3 2. When solving an inequality, we arrive at letter 1d465 plus 2 letter 1d465 plus 32 3. Explain what our solution set is. 3. When writing our solution in interval notation, how do we represent all the real numbers? 4. When solving an inequality, we arrive at explain what our solution set is. 5. Describe how to graph letter 1d466 equals letter 1d465 minus 3 algebraic for the following exercises. Solve the inequality. Write your final answer in interval notation. 6. 4 letter 1d465 minus 7 less or equal to 9 7. 3 letter 1d465 plus 2 greater or equal to 7 letter 1d465 minus 1 8. Minus 2 letter 1d465 plus 3 letter 1d465 minus 5 9. 4 letter 1d465 plus 3 greater or equal to 2 letter 1d465 minus 1 10. Minus 12 letter 1d465 less minus 54 plus 25 letter 1d465 11. Minus 5 letter 1d465 minus 1 plus 3 letter 1d465 minus 4 letter 1d465 12. Minus 3 2 letter 1d465 plus 1 minus 2 letter 1d465 plus 4 13. Letter 1d465 plus 38 minus letter 1d465 plus 55 greater or equal to 310 14. Letter 1d465 minus 13 plus letter 1d465 plus 25 less or equal to 35 for the following exercises. Solve the inequality involving absolute value. Write your final answer in interval notation. 15. Letter 1d465 plus 9 greater minus 6 16. 2 letter 1d465 plus 3 7 17. 3 letter 1d465 minus 1 11 18. 2 letter 1d465 plus 1 less or equal to 6 19. Letter 1d465 minus 2 plus 4 greater or equal to 10 20. Minus 2 letter 1d465 plus 7 less 13 21. Letter 1d465 minus 7 minus 4 22. Letter 1d465 minus 20 minus 1 23. Letter 1d465 minus 34 2 for the following exercises. Describe all the x values within or including a distance of the given values. 24. Distance of 5 units from the number 725. Distance of 3 units from the number 926. Distance of 10 units from the number 427. Distance of 11 units from the number 1. For the following exercises, solve the compound inequality. Express your answer using inequality signs, and then write your answer using interval notation. 28. Minus 43 letter 1d465 plus 2 less or equal to 1829. 3 letter 1d465 plus 1 2 letter 1d465 minus 5 letter 1d465 minus 730. 3 letter 1d4665 minus 2 letter 1d4667 plus letter 1d46631. 2 letter 1d465 minus 5 minus 11 or 5 letter 1d465 plus 1 greater or equal to 632. Letter 1d465 plus 7 letter 1d465 plus 2 graphical for the following exercises. Graph the function. Observe the points of intersection and shade the x-axis representing the solutions set to the inequality. Show your graph and write your final answer in interval notation. 33. Letter 1d465 minus 1 234. Letter 1d465 plus 3 greater 535. Letter 1d465 plus 7 less 436. Letter 1d465 minus 2 737. Letter 1d465 minus 20 for the following exercises. Graph both straight lines, left-hand side being y1 and right-hand side being y2 on the same axes. Find the point of intersection and solve the inequality by observing where it is true comparing the y values of the lines. 38. Letter 1d465 plus 3 letter 1d465 minus 439. Letter 1d465 minus 2 letter 1d465 plus 140. Letter 1d465 plus 1 letter 1d465 plus 441. 12 letter 1d465 plus 112 letter 1d465 minus 542. 4 letter 1d465 plus 112 letter 1d465 plus 3 numeric for the following exercises. Write the set in interval notation. 43. Letter 1d465 minus 1 letter 1d465 3, 44. Letter 1d465 letter 1d465 greater or equal to 7, 45. Letter 1d465 letter 1d465 4, 46. Letter 1d465 letter 1d465 is all real numbers. For the following exercises, write the interval in set builder notation. 47. Minus infinity 6, 48. 4 infinity 49. Minus 3 5, 50. Minus 4 19 infinity. For the following exercises, write the set of numbers represented on the number line in interval notation. 51. A number line with 2 tick marks labeled -2 and 1 respectively. There is an open circle around the -2 and a dot on the 1 with an arrow connecting the 2. 52. Number line with 2 tick marks labeled -1 and 2 respectively. There is an open circle around the tick mark labeled and a line that extends leftward from the circle. There is a dot around the tick mark labeled 2 and a line that extends rightward from the dot. 53. Number line with 1 tick mark labeled 4. There is a dot on the tick mark and an arrow extending leftward from the dot. Technology for the following exercises. Input the left-hand side of the inequality as a y1 graph in your graphing utility. Enter y2 equals the right-hand side. Entering the absolute value of an expression is found in the Math menu, num1, abs. Find the points of intersection, recall, second CALC5. Intersection, first curve, enter, second curve, enter, guess, enter. Copy a sketch of the graph and shade the x-axis for your solution set to the inequality. Write final answers in interval notation. 54. Letter 1d465 plus 2 minus 5 255. Minus 12 letter 1d465 plus 2 456. 4 letter 1d465 plus 1 minus 3 257. Letter 1d465 minus 4 358. Extensions 59. Solve 3 letter 1d465 plus 1 equals 2 letter 1d465 plus 360. Solve letter 1d465 2 minus letter 1d465 1261. Letter 1D465 minus 5, letter 1D465 plus 7 less or equal to 0. Letter 1D465 not minus 762. Letter 1D45D equals minus letter 1D465, 2 plus 130 letter 1D465 minus 3000 is a profit formula for a small business. Find the set of x values that will keep this profit positive. Real-world applications 63. In chemistry, the volume for a certain gas is given by letter 1D449 equals 20 letter 1D447, where V is measured in cc and T is temperature in OC. If the temperature varies between 80 OC and 120 OC, find the set of volume values. 64. A basic cellular package costs $20 mo. For 60 min of calling, with an additional charge of $30 min beyond that time. The cost formula would be letter 1D436 equals 20 plus 30, letter 1D465 minus 60. If you have to keep your bill no greater than $50, what is the maximum calling minutes you can use?